Welcome back, everyone. We are here for day 3 of the completely free CCSK Certificate of Cloud Security Knowledge training program to prepare you for the CCSK version 5 exam. My name is Mike Gibbs. I will be your host throughout this process, and we'll be continuing our discussion on cloud security. So everybody that's here, it's been really wonderful working with you all week. I've loved having you here. Hope you all learned a lot about security. Before we begin, I want to remind you of a couple of things. If you're just joining us, like maybe you just found day 3 on the first time, I want to remind you can go back and check day 1 and day 2 of the completely free CCSK training. My team will drop those links in the chat box for you, because if you just started now, that's fine. Join us, but go back and catch the other stuff too. The other things that I wanted to let you know is that my team created a study guide out of the training materials that I created. So please go sign up for that free study guide. It's about 400 plus pages. It's fairly comprehensive, and it's really going to help you study for the CCSK exam as well as other cybersecurity exams. And it's free. So go get it. While we're at it, the description of this video has so many things to help you in your career. Guides on how to win an interview, for example, things you might need to learn to become an architect, for example, and that's all there free. And of course, tomorrow we have fun. We get to do our once a week how to become an architect webinar. Tomorrow's webinar, which will be at 11 a.m. Eastern. They're normally 1 to 3 p.m. Eastern, but this week, because of the free boot camp, we're doing it earlier. Tomorrow's focus is on how to become a security architect. We'll talk about everything we do as a security architect, all the skills you need, and it'll be lots of fun. We'll have about 60 to 90 minutes to just have conversations on Zoom, and I'll do anything I can to help you in your career. So join us tomorrow. It's free. And if you don't catch us tomorrow because you're catching this months later, you can always join us on the 1 to 3 p.m. webinars. We'd love to see you. So we are going to continue our discussion from yesterday. We got a couple more days of cybersecurity training and cloud security training. So let me know you're awake, you're alert, and you're oriented by giving me a hashtag CCSK. And as soon as I see those CCSKs, Chris is going to start the content for us. So I'll wait for the first CCSK to come in, and then we'll start our content. But in the meantime, while I wait for that, I hope you're all having a great time. I hope you're learning a lot. I hope you're as excited by cybersecurity as I am, where you started and learned a little, and you went, wow, I love this. And you learn more, and you learn more, and you learn more. All right, I see from Pablo, the first CCSK is coming in. That means more follows. Chris, let's roll with the content. Now let's discuss service authentication and service accounts. So a service account is typically created when one system needs to access another system. So for example, we might have a 3-tier website where we've got web servers, app servers, and database servers. And somehow the app servers need to send information to the database. Now, for that to occur, we typically need some way for the application servers to talk to the database. And that's typically something called a service account. And that will basically be some flavor of IAM to enable the systems to talk to the other systems. So we'll talk about built-in service accounts. Now, there are many applications like Microsoft SQL Server that actually include predefined service accounts. And they're there to make it very easy to connect to other systems. Now, let's talk about password management. So when we're dealing with service accounts, they're typically configured with some kind of non-expiring password because of the automated nature of their tasks. So, if we were going to use a password, that would be a password that would be there for a long period of time. Typically use tokens or other devices for these types of service accounts for that reason, because if we're going to do passwords, it's going to require password updates potentially by third parties if we're dealing with third-party systems. And the point is we're going to have to get fairly complex if we're going to use passwords, because they're going to have to be something that's very hard to crack. But often we use other forms of things where we're constantly using tokens and things that change back and forth between these service accounts. So let's talk about some service authentication with regards to a service, our security policies. High privilege levels are going to necessitate very strong password security measures. So we have to make certain accounts, potentially accounts that have high access. We have to be very careful with them to prevent other people from logging in, trying to guess it, try to get to these passwords and being successful. So to authenticate a service, we could use a certificate-based authentication. And this is going to be an alternative to the traditional username and password, and it's going to use security certificates to do this. This is much better. Let's talk about some APIs for web services, and these are going to have different ways and different API methods to basically exchange information. Now, they're exchanging information for various things, so we have to be careful how these APIs and how they're secured, specifically for web services. Now, let's talk about mutual authentication. So this is going to be required when both the client and the server are going to need to make sure they to confirm each other's identities. And that way the client and the server, or the server and the client, or the client and the client, or the server and the server, or whoever parties need to talk to each other, are sure that the other party is who they claim to be. Now, digital certificates are going to make this a lot easier. They're going to help a lot. And that's kind of what we're typically talking about. And remote work is a good example of mutual authentication. You want to set up an IPsec VPN tunnel from your home to your corporate VPN concentrator or the cloud-based VPN concentrator. The company can't let you on the network without knowing you are or who you claim to be. You can't be allowed on the network until they know you are who you claim, and you don't want to get bad information. So you have to mutually authenticate each other and authenticate each other and make sure you are who you claim to be. And typically speaking, VPN servers do this. And some of them do it with digital certificates. Some of them do it with shared keys. But there's definitely a way that the devices have to authenticate each other. We can also use something called dual layer authentication. And that ensures communication sessions start only after a good, successful authentication on both sides. So what's the security implications here? We want to prevent attackers from redirecting users to a rogue VPN service, for example, and we need to make sure everybody is who they are before doing anything. Let's talk about implementing IAM, and there's a lot of different ways that we can do IAM. So we'll talk about centralized access control. And that's going to be where we have this authorization, and which means who can do what, and it's going to be managed by a single entity. We can also go decentralized access control. And here, the authorization verification is going to be performed by multiple entities across the system. Centralized, one location. Decentralized, potentially in many locations. So if we think about centralized access control, and it's managed maybe by a team of people for the company, it's a small team, and they're in one type of a location, in a high availability location, albeit, it's going to be fairly low administrative overhead. We know exactly who's making changes. It's relatively easy architecture to actually design this, and we can scale this very big. All we have to do, typically speaking, is add more domain controllers. So without Active Directory in the data center, we just need extra servers, and we get bigger and bigger and bigger. Now, the vulnerability here, the weakness is you've got a single point of failure. So maybe you need to be able to have a primary and a backup site, but that's the challenge. Now, if we do decentralized access control, now we've got management of authentication and authorization by multiple teams in multiple parts of the world. So this is going to have a lot of administrative overhead because changes have to occur across all these boundaries. People need to be coordinated. Consistency maintenance, we're making sure that we're doing things in a consistent way. It gets a little harder this way. And we have to think about the challenges that are associated with that. So ultimately, centralized, decentralized, it's going to be a trade-off. We have to figure out which trade-offs make sense. Let's talk about single sign-on. Now, single sign-on is going to provide a IAM type environment that's going to enhance convenience and in some ways can enhance security. And I'll talk about why. So single sign-on is basically where you sign on once, you get your authentication and your authorization, and then you're allowed to access any system because they've already proved that you are who you claim to be. Now, the weakness here is if you get access to whatever it is that you prove who you claim to be, now you can access everything. The enhancement in the user experience, meaning if I have to log in 50 times a day and each login takes me a minute, well, I'm losing 1 out of my 8 hours per day. The other side of this is sometimes single sign-on can actually enhance security. And the reason is when people have to remember too many usernames and passwords, they actually do scary things with their passwords, like sticky notes on their desk or storing them in a clear text file on their hard drive or something like that. So in many cases, single sign-on actually enhances security because of those reasons. It enhances user convenience. It strengthens security by minimizing password fatigue, and it really simplifies some of the overhead and administrative tasks unnecessary for users to be able to access their accounts. The real concern here is the potential for a security breach, because if you get access to that one user's access, they have now access to many more resources. So with centralized access control via single sign-on, it's basically going to be using a directory service like Active Directory, and it's going to have a central repository, typically speaking, for the user and resource data, and it will include authentication details for access management. We could have directory services in LDAP. You may hear this lightweight directory access protocol, LDAP. Microsoft Active Directory is a key component of and a good example of an LDAP-based directory. So when we're dealing with LDAP and centralized type control, we're going to have some kind of authentication and privilege-based access, just like anything else. We have to make sure the users are who they're supposed to be. And then these directory services will determine what the person's permissions are, which is the authorization. Mike has the permission for this server. He can access it. Mike doesn't have the permission for this server. I cannot. Now, I want to talk about a little bit about domains and trust relationships. So there are ways to employ multiple different environments and connect them together for organizational access control. And what will happen is we might have multiple domains, and each one will upload a specific security policy. And then we may want to link them. So let's say we've got company A. And company A that we have, for example, actually, maybe I'll whiteboard this one out for you. I think it'll actually help. So, because if we start talking about mergers and acquisitions, I think this might show you some ways where we can actually find these situations. Bear with me 1 second, and then what I'll do is I'll whiteboard this out for you. Okay, so let's go to my whiteboard here, and what we're going to do is I want to show you what we're really talking about. So let's say we have company A. And if company A, for example, they have their own directory services that does their IAM. Does their IAM for their organization. So they've got their own IAM systems. Now, let's say company B decides to merge with company A. Now they have their own independent IAM systems. So we can develop what's called a trust relationship between these. Oops, didn't mean to do that. So we can create a trust relationship, and in this trust relationship, what can ultimately happen is a person could log into company B after they're a merged company, for example, or with this environment, and then they can ask company A's directory services to actually allow them access because they're sharing information. So when we talk about domains and trust relationships, it's basically like my friend Joey is my friend. So I trust Joey. So when Joey tells me stuff, I believe it to be true. When I tell Joey stuff, he believes it to be true. So we can be dealing with exchanging IAM information like this or other types of information in general in technology. But that's typically we're talking about the domains or each other's own area or business, what have you, or whatever area is being controlled over the IAM system. And then we can trust or form link relations. So let's talk a little about federated identity management. So federated identity management often works with single sign-on, where we take a cloud provider's IAM systems and we connect them to another identity provider. So federated identity and access management is going to enable sharing IAM information across multiple entities. So just like that example I showed you, we've got two entities and they're sharing IAM information across them. And there's lots of ways this can be done. But federations really allow groups of organizations or single organizations or other people to basically use access to other people's information. You may ever log into a website and it says, log in with your Facebook password, your LinkedIn password, your Amazon credentials. What happened is that organization went to an identity provider like LinkedIn and is using their identity systems in a federated environment. So that's what we're typically talking about with regards to federated IAM. It enables resource sharing across identity and access environments. It can often enhance user experience because you might have a user that doesn't have to access the credentials to go across two different systems. But, if you're connecting two different IAM systems, we have to make sure that we connect them somehow. There's typically some languages we typically use like SAML or OAuth or OpenID Connect, OIDC. So these are things that typically can be used. We can also use third-party services in federations that we could potentially be dealing with. So we could be connecting to a third-party service. And many corporations use these types of technologies all the time. Federated IAM is very common in the world today. Especially with cloud-based federations, we're going to find ourselves many, many times where we're going to need to federate identity. So it could be a situation like this, where we could have a private data center, private cloud, and then we might have, let's say, we have users sitting on the AWS cloud, and servers that are sitting over here. And let's say we've got a link between these two devices, say a private line, direct connection, whatever you want to call it. We can have an environment where a user goes to access a system that's over here, and then the AWS Identity and Access Management System that determines who you are, what you're allowed to do, and then keeps track of what you've done on AWS, will then ask the Active Directory servers or whatever servers are sitting in the organization's data center if it's okay. And then the users in the Active Directory respond, yes, the user can access the system, and then the user will get access to the system with AWS, even though what actually was behind the scenes was their Active Directory server. With a lot of cloud-based federations that were in cloud computing. And the key here is we're looking for some kind of a seamless login. Make it easy, the user logs in. But I also want to talk about the reality and the complexity of this and why this is going to be done. So if you really think about the modern world, in the modern world, 98% of enterprises are multi-cloud. So imagine you've got an AWS cloud over here, and they have their own IAM systems. And then you've got an Azure cloud over here. And this is reality for most enterprises. And then also you've either got a private cloud or a Google cloud. Who cares? It really doesn't matter. Then maybe the only way to deal with this in a good way is to actually have like a cloud access security broker or a central IAM, whatever you want, and have all these sites federated. And by doing so, what's going on is you're managing your identities in a very good, secure location and environment. But it's scalable because you're not going to find yourself in an environment where you've got 3 different identity and access things. So this is going to be commonly done with cloud-based environments. Now, we may also have something called a cross-organization federation. And that's basically just sharing identity across 2 different companies. Company A makes cars. Company B makes tires. They want to share information between them. That's typically a cross-organization federation. We could also do something called scripted access. So we can create things like login scripts to help users log in. And scripted access may automate the entry of login credentials and start a session. And it almost in some ways mimics single sign-on because it allows users to bypass manual logins across servers by whatever was placed in the script. Now, this is going to be useful in environments of organizations that don't have very good native single sign-on characteristics and are looking for a temporary fix. Here's the reality in today's world, especially if we're in cloud computing. Because cloud computing's boundaries are very soft. If we don't have the ability to do things like single sign-on, we probably need better systems and should upgrade. So if we think about the concerns, the security concerns of scripted access, now we have to have very secure storage for the script. Is the script plain text? What kind of sensitive information is in the script? So we have to be very careful with that. I'm going to talk a little bit about session management for controlling access. Imagine logging into your system being attached to the network, and then just go and walk away for an hour, not locking your screen. Now, this could potentially be a disaster. So what do most companies do? They make sure your screen locks out after a couple minutes of inactivity. So it's a protective control to put in place. So let's talk about the IAM life cycle. So it really involves creating the accounts, managing the accounts, and then deleting the accounts when we're done. And these activities are going to be critical for access control, because if we don't delete accounts when people no longer work for us, they'll still be able to access our systems, for example. So we need to be very careful what we're actually using. We need to make sure that we enable user authentication, we provide the proper authorization, and then we support the correct kind of accounting. So let's talk about provisioning and onboarding. Let's talk about a secure account creation process. It needs to follow the organization's security policies. And in many cases, the organization will have to create specific procedures or processes for the way things are done. We don't want random or whimsical actions, because that's when things break and we have inconsistencies which cause vulnerabilities that could be used as an attack vector to us. We need to make sure that the person is given a username or some form of unique identifier. Now, typically it means a full name as well, potentially more details. And if we're going to be dealing with biometric authentication, where it's going to collect and store information during provisioning, we're going to have to collect that information like the fingerprint. Now, during that provisioning of the new user, we have to make sure they are who they claim to be. So we're checking photo IDs. We might be doing background checks, security clearance, fingerprints, all that stuff. Drug tests potentially. And in many organizations, the provisioning of the accounts for the users is actually done behind the scenes by HR. HR puts something in the screen that says new hire, and then it automatically creates accounts for the people. Now, this brings us into an effective way to deal with this group or role. So there's a couple ways we can do access control, and we're going to talk more about access control, but I want to talk about the ridiculousness of one approach and then why we typically use role-based access control. So one approach with IAM would be when we have users and we create a user account, what we do is we create, if we have 100,000 users, we would create 100,000 accounts, and we would manually go to every single account and say, Mike's allowed this, this, and this, but not this. And then I'd go to Nick's account. Nick is allowed this, this, and this, but not this. Dimitri's allowed this, this, and this, but not this. Aguilar's allowed this, this, and this, but not this. Apostoli's allowed this and this, but not this. That's going to get us in trouble because it's going to be labor intensive and human error. So what happens is we use something called role-based access control, which is basically you create a group or a role. And what I mean by this is, let's say you've got sales reps. So you create a group of people called sales reps, and you put all the sales reps in the group. And then you determine the permissions that the sales reps need. And that way, instead of trying to apply permissions for everybody and taking millions of hours and making mistakes, you create the 10 or 15 or 20 or even 50 roles or whatever it is that you need, apply permissions to that roles. And as soon as HR hires them, that automatically in the system, and they will be given the right role based upon their job, which will have the right permissions based upon their job. Typically speaking, when we hire someone, that's going to be when the HR kicked off all these things. It's going to order the systems that'll be given to the person, like a laptop, mobile device, token, smart card. And it's going to be really important to maintain accurate records here. We have to be just as meticulous with offboarding. We have to cover, when someone leaves, we have to get our equipment back. We have to make sure that there's no data stored in the wrong places. So we have to delete the accounts and audit the accounts and everything that's necessary. So from the beginning, whether we're setting up a new employee, we have to make sure that they can get on securely. We have to make sure any IAM settings are set up, two-factor authentication, what have you. So with deprovisioning, when an employee leaves, we have to make sure we get that equipment back. The accounts have to be terminated. They should be immediately disabled to prevent unauthorized access. Supervisors and realistically need to review and salvage any data from the user's accounts. Encrypted data access is going to be facilitated by changing and sharing the user's passwords with supervisors if need be. And then there'll be an account deletion policy. Typically, a disabled account should be deleted within 30 days, but organizations may have different timelines based upon needs, what have you. So if we don't delete the account quickly, we have a higher risk of sabotage. And typically speaking, if someone leaves and they're disgruntled, they may want to harm the company, and there's potential for misuse of the systems and harm. So we have to be very careful about this. We have to collect the hardware or anything that's attached to our systems. We need to have accurate records of what was issued to people so we know people aren't leaving with our equipment, but also take. All right, we are back. So let's see if anyone has any questions. As you can tell, I added a lot more IAM to this curriculum that was standard with the CCSK, like I mentioned on the first day. And we have one more IAM session. I actually went to the depth that you would get on a CISSP exam for the IAM. And the reason is with all these soft boundaries in the cloud, IAM has become much more important. So I wanted to have more knowledge to make you better. So let's see if there's any questions. If they are, let me know in the chat box. And while I wait to see if there are any questions, and if not, we'll go back to the content. I'd like to remind everybody that tomorrow we have our free How to Become a Security Architect webinar. Once every Thursday, we run an architect webinar. This one is going to be How to Become a Security Architect, and it will be 11 a.m. to 1 p.m. tomorrow. We'll go over the role. We'll talk about what we do. We'll talk about the skills needed for the role, and then we'll answer any questions you have live on Zoom about your career or any other architecture career you desire. And it's free, so join us tomorrow. I also wanted to remind people that there is a free guide in the event you just joined us right now that will help you. It's a comprehensive 400+ page guide of cheat sheets to help you pass the CCSK exam or the Certificate of Cloud Security exam. And it's the companion to our Certificate of Cloud Security Knowledge Training course. So let me see if a couple of questions come in. And if no questions come in, we'll get right back to the content. And we do have a lot of content to cover. I don't know about you. Let me know in the chat box. Do you all love security as much as I do? Do you all find it as interesting as I do? Because I love cybersecurity, physical security, executive protection. I've actually studied all forms of security in my life. Wanted to make sure I could protect my wife, so I studied executive protection when I was younger, bodyguarding thing. It was only for family purposes, but I just always loved all kinds of security. Well, I don't really see any security questions popping up, so please give me a hashtag CCSK so that I know you're here. And if you're enjoying the content, please hit the like button. If you're not a subscriber and you're enjoying the content and you want to see more content like this, please subscribe and hit the bell. Anyway, Chris, let's get back to the content. Wait, I think there is one question. What is generic AC? Could you be a little more, help me with what you mean by AC? Because AC could mean with meals, AC could mean air conditioning, and I really don't know what your AC actually is. So I'll wait to see if there's an answer there. Not sure what you mean there. So what we can do is, if I don't see the question further explained now, if you'd like us to later, we're happy to explain it. I just don't want to guess. I mean, AC could mean access control. But then again, we talked about the types of access control, like role-based access control, context-aware access control, role-based. So I'm not really sure what you mean. But if it comes up, let us know and we'll answer it at the next question session. Chris, if you want to get back to the content. So how do we define a role? So if we go back to that concept of role-based access control, we pick a role based upon the person's job. But roles need to be relevant and they need to be changed over time. So let's say I have a systems administrator and they're happy in their job and then they go get an MBA and all of a sudden now they're in management. They no longer need the systems administrator access, and now they need manager access. The systems administrator may have greater access to more parts of the system that could cause harm, and that needs to be disabled immediately. And now the person needs to be access to management systems. So we always go back to that principle of least privilege and security. Don't give people more than they need to know to do their job, and that is going to be widely part of the zero trust architectures that we will be using as well. Now we need to review privileges, which means periodically checking accounts and make sure the users have what they're supposed to. Not only will this enhance compliance, but it will also protect the organization, but it also protect against what you call privilege creep, which you've had 10 jobs, and as you change jobs, they didn't accidentally remove privileges from all jobs, and you have too many permissions. Organizations can also use scripts for account management to identify and disable inactive accounts, for example. And they may want to do this as well. Organizations will be doing routine auditing on privileges and group memberships. We really have to be very careful of monitoring privilege levels and high privilege accounts, because they're the ones that can cause the majority of the challenges. As I mentioned, we have to adjust privilege creep where an employee works in 10 different places and then they have a certain level of privileges. So we have to make sure that we keep privileges access. So let's talk a little about permissions. And basically they define access to objects such as files or applications, things like creating something or reading something or deleting something. And permissions can encompass access rights, and it kind of makes them permissions, we start thinking authorization. A lot of the stuff gets pretty jumbled up in similar context. So we have to figure out what kind of permissions. For example, a person might have read permissions to be able to read something in a folder, but not write or delete permissions. So that's all what we're typically talking about. Now, rights basically focus on the ability to perform a certain action. Examples include modifying system time or restoring system backed up data. And they're distinct from permissions. So even though these things sound so alike and they're used so interchangeably, there's technically a difference. Technically. And privileges are typically a blend of rights and permissions. Administrators typically possess full privileges on a computer, and they typically have excessive rights for pretty much anything they would need to do. Very high rights as a systems administrator, which is typically what you'd want on the computer that you bought for yourself. But you might not want that for all of the systems, for example, inside of an organization. Let's talk about authorization mechanisms. We talked a lot about authentication. Now let's talk about authorization mechanisms. So we can use something like an implicit deny. And we typically do. So you're allowed to access this, 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 and this, and just nothing else. Think like a firewall. Only whatever's allowed is in, and everything else is just blocked. Now, we may want to create something called an access control matrix. And this is really just going to be a table that's going to list subjects, objects, and privileges. And by doing so, and we create this little chart that tells us the subject, what the person, the objects, and the privileges on each object, it's going to make us easy for us to be able to see it and plan it. Let's talk about content-dependent controls. And content-dependent controls are access controls that are going to regulate data access beyond the context of an object. So for example, in a database, we could actually create a view that is context-dependent or content-dependent that's going to be controlled by selecting specific columns. So what we're really dealing with is determining who can actually access what information. So we consider a scenario where a customer table contains various fields, maybe names, email addresses, phone numbers, and credit card data. A content-dependent view might display only the customer names and emails and exclude the other versions, which dramatically enhances security by not presenting information to those that don't need it. And users can get access views to certain things, but what they're only seeing is the restricted data, and they may not even know that there's access to other data. And with this kind of context-dependent control, the access controls can vary based upon contextual factors as well. And these controls can adapt across permissions and control the user, the resource environment. And the more adaptive we get in context-dependent, the greater our security becomes. For example, we could restrict access or that was granted because of the time of day. Somebody's supposed to log into a system at the wrong time of day. Block it, for example, or the wrong IP address or being in the wrong part of the world. Now, we've talked a lot about principle of least privilege. We'll talk about need to know, which is similar, but again, it's different. So need to know is making sure that the subject only has access to what they need to know to perform their job duties. Where principle of least privilege is access have the subject have access to only what's needed to do their job. So need to know is more related to information. Principle of least privilege is more related to access and what you're allowed to access. Let's talk about discretionary access control. And basically here we have an owner that has the ability to permit or deny access. This owner has the ability to grant or refuse access to any way they want. So if you think about a folder on your system, on your PC, on your Mac, on your Linux thing, you can share that folder to anyone you want. And you can say, Mike can access this, Billy Bob cannot, Sally can, Miley can. You can do any of these kind of things that you want. And kind of keep this in the back of your mind, what you're thinking about. So with regards to discretionary access control, it typically works via it's called an access list. I like the way the operating systems have access lists for permissions. You're typically thinking about of who can access what. Microsoft Windows uses discretionary access control, for example. But the key to remember with discretionary access control is it's not managed centrally. It's managed by the owner. So if we had discretionary access control on a company with 1 million users, the 1 million users could be determining how they're sharing information. Now, we also have the concept of non-discretionary access control, and this is going to be managed by administrators, and administrators can implement system-wide changes. So let's talk about management of non-discretionary access control systems. It's going to be centralized. It's going to be simple to manage. It's going to be less flexible because it's going to be central, and we're going to need to enforce strong policies, and it's not going to be the user that can do whatever they feel like. But any access control that's not based on discretion is considered non-discretionary. I mentioned role-based access control, but it uses that concept of users and groups. And basically speaking, when we hire someone, we determine their job function and we determine the privileges they get for those job functions. Role-based access control has been widely used for decades for this reason. It's scalable. It's easy to set up. So with role-based access control, we set up these access controls are basically permissions based upon the person's job functions or roles. The decisions that they're going on are going to be based upon rules. And the rules basically will be set of, sales rep just doesn't need to access this, so they won't be able to do it. And this kind of really makes it fairly easy to do things on a managed IAM from a large system in a scalable environment. We can have it driven via policy. So anytime we have the opportunity to do something via policy, push it, it enforces the standards we ultimately have. Now we could do something also called attribute-based access control, which is going to be rules that are going to implement multiple attributes. Now this offers greater flexibility than rule-based methods as rules are applied to everyone. And this means that rules are not applied uniformly to every single subject because this is going to work off of policy. So again, it's giving us more opportunities than just standard IAM. We can do mandatory access control as well. And basically, we're going to use labels and apply those labels to subjects and objects. And the users will have labels based upon their clearance level. And you may hear this called the lattice model. We can also do something called risk-based access control, which is going to grant access after evaluating risk. And this kind of risk-based access control you typically uses machine learning for some form of analysis. Let's talk about implementing federated authentication systems. We typically use something called SAML here, or Security Assertion Markup Language. And that's going to be an open standard that's going to be used for authenticating and authorizing data between parties. Typically speaking, between an identity provider and a service provider. And SAML is going to be commonly used for single sign-ons, for enterprise type environments. And there are going to be some key elements and components that are going to be associated with SAML, something called assertions, which are basically going to be XML documents that the identity provider is going to send to the service provider. And these assertions will contain statements about a user's identity, attributes about the user, entitlements of the users. And there's typically 3 types of assertions. There is an authentication assertion, an attribute assertion, and an authorization decision. And the authentication assertion really provides proof that the user is who they claim to be. The authorization assertion indicates what the user is allowed to access. And the attribute assertion could be any kind of information about the user. Now, in this environment, we have the identity provider, which is the system that provides the identities. And this includes the capacity to authenticate and provide assertion services. Now we have the service provider, which is the systems that provides the actual services to the user. Now the service provider rolls on basically relies on the assertions from the identity provider to determine what to do. So what does this look like? Again, so we might have the identity provider, and the identity provider could be, realistically speaking, some Active Directory servers inside of the private cloud. The identity provider could also be a cloud access security broker, or it could be something like your Facebook account or Google account. Google's a big identity provider, and realistically speaking, what we're really talking about is, connecting maybe your AWS systems to the Google identity provider and getting information from them. Where AWS would be the service provider and Google in that case would be the identity provider. So what happens, there's going to be something called the SAML request and response. So when the user logs in or tries to log in, for example, and maybe the best way to do this is to go back to here. So as soon as there's a request to log in, let's go back to the cloud provider. As soon as somebody tries to log in over here to the cloud provider, what has to happen is we're going to get the SAML request, and it's going to be sent to the identity provider. And then the identity provider is going to provide that SAML response back, which is going to tell the service provider how to act, what to grant, for example. Now, this can also be done with something called OAuth. So OAuth, or Open Authorization, is an open standard for access delegation, and it's commonly used as a way for internet users to grant websites or applications access to information, but without giving them their passwords. And it's done through a process known as secure third-party user agent mediated authorization. And basically speaking, you're going to allow one system to access another system without passwords. So what's going to happen here is it's going to specify a process for the owners to authorize a third party, and then OAuth will effectively provide a token for it to do so. And many of you are used to this all the time. So let's say you had one system that had to integrate to another system. And I'll draw that out so you might want to so you could see what I mean by this. Let's say you had a lot of social media that you actually did, and you had an Instagram account, for example, and then you had a LinkedIn account. And then you had a YouTube channel. I don't know. We're just having fun with this here. But I want you to, let's just bring it here. So now it would be quite possible for users, and then users could basically log into each device. Imagine a company that gets millions of these posts and things, millions of responses every single day across their platform. Now they could manually log into Instagram, manually log into LinkedIn and comment on this platform, manually log into YouTube. Or they could go to a social media management software. And what would happen is they could go to this social media management software and be able to respond to comments across the platform. So typically what has to happen for this to occur is the social media management platform is going to need some kind of information, the ability to connect to this. And for this to occur, do you want to give your username and passwords to the social media manager for all your accounts? What happens when they get hacked? Then all your social media accounts get hacked. So people don't do that. So what happens is when you log into your social media management software, it'll redirect you to, say, the Instagram website. You'll then log into the Instagram website, and all of a sudden in the future, you'll be allowed to access. So in many environments, we have this type of a world where we're using these authorization and authentication systems across them. And that's an example of when we use OAuth, where basically you've got one system, it logs into another system, it connects to the other system, and then you're using it. Now, there's a couple of versions of OAuth. There was initially this OAuth 1.0, and that was the initial version that was introduced, the framework of OAuth. Then we moved to OAuth 2.0, which is a much more flexible and simplified version that allows authorization from web applications, desktop applications, mobile phones, devices. but it's not backwards compatible with OAuth version 1.1. That OpenID is an authentication protocol that can also be used for authenticated users by cooperating sites. And OpenID is a protocol for authenticating users. And it's typically used as a third-party service for user authentication. By implementing federated authentication systems with OpenID, it eliminates these ad hoc logins. It can provide a single identity. A user can log into multiple sites without using unique credentials for each. It provides a great authentication layer to serve as an authentication protocol on top of the OAuth 2.0 framework. And it's really providing this kind of dual functionality of both authentication of who you are and then authorization of what you can do. And this, of course, is managed by the OpenID Federation. Now, there's been some advances from OpenID. It builds upon the original OpenID specification, but with more modern technologies. It now uses JSON web tokens. And realistically speaking, you can do a retrieval of a web service, and a web service is going to be used to fetch these JWIs. Another IAM protocol we could be using is Kerberos. And Kerberos we may be using for single sign-on or user authentication. It can protect credentials, for example, and it can safeguard user login from unauthorized access. And it uses symmetric key cryptography with AES encryption. Now, Kerberos ensures confidentiality and integrity, protecting against eavesdropping and replay attacks. And think about role consideration. Roles can basically be centralized on a single server or distributed across multiple servers to enhance performance. With Kerberos, typically there's a key distribution center, which is going to act as a trusted third party for authentication services, and it's going to maintain secret keys for all the network entities. We'll have the concept of an authentication server, and that's going to be a key component of the key distribution center, which is going to verify the authenticity and the timeliness of the tickets that can host the ticket granting service, for example. We will have a ticket, which is going to be an encrypted message that authorizes a user to access a web service. And we may have something called the ticket generating ticket. And the ticket generating ticket is going to be a special ticket that's going to confirm a user's authentication by the key distribution center. We'll talk about a Kerberos principal, which is any entity, usually a user, that can request or receive information from Kerberos. And then we'll talk about the Kerberos realm, which is going to be a logical network covered by Kerberos, where principals can obtain tickets. Kerberos also has typically an account database, and that's going to be typically integrated in a directory service like Microsoft Active Directory. And there's going to be a mutual authentication because Kerberos is going to exchange tickets to verify and identify and authenticate clients where they're going to be. IAM in the cloud is a little bit different than it is in the data center. There's obviously a clear division of the responsibilities between the cloud service provider and the cloud's customers. Now, with the cloud providers, they typically have some unified interfaces for managing resources. And in some cases, these interfaces could actually be exposed to the internet. So obviously, if that's the case, it'll need to be locked down and really secured. But in most part, there's going to be IAM between organizations. There's going to be IAM between cloud providers. There's going to be a lot of IAM across organizations that we're typically going to be dealing with when dealing with cloud computing, especially because almost everyone is multi-cloud. So when we're dealing with cloud computing, we typically have this kind of multi-organization approach where IAM is going to span multiple organizations. And potentially speaking, especially if we use organizational hierarchies and other types of things that could further complicate it. We're going to have varied IAM systems, meaning, in the data center, we typically use the same kind almost in every data center in the world. And now Amazon's got their own IAM and Google's got their own thing and Microsoft's got their own thing. Now, that's going to add a whole heck of a lot of complexity if we have to manage 3 different systems. Of course, if we federate it, we don't have these problems. So, cloud providers try to come up with a unified management interface to make it easy so you can do it in a web console via an API. But if we do that and expose to the internet, now that even further reduces our security and enhances our risk. So we can talk about ways to do this. We can federate to multiple IAM systems. And this is very commonly done. But if we think about it, if we use federation and a centralized type environment, that single environment becomes very critical. It also becomes a single point of failure. So we just have to think about how we're going to architect this and evaluate the trade-offs of these things. IAM is going to be really critical to cloud security. And IAM always mattered, but remember in the beginning, I showed you how cloud computing has very weak parameters compared to a normal environment. In the normal environment, your internal stuff is way far away from the internet, so to speak, from a routing perspective. In the cloud, you could be in a VNet, and all you have to do is add a default route, and all of a sudden your systems are on the internet. So because of these softer boundaries, IAM pretty much becomes one of the few things we talk about. I talked about role-based access control. I talked a little bit about attribute-based access control. We can use policy-based access control. And the reality is we're going to need to be moving up into context-based access control. That's going to be looking at a lot of different contextual factors, where the users are, the time of day, their IP address, their devices. We're going to have to combine it all for modern security. Now, as a reminder, I want to make, because this is going to be heavy CCSK kind of terminology now that I'm getting into for the exam, we may have something called an authoritative source when it comes to IAM, and that's going to be the trusted system holding the accurate data, like an HR system, for example. We may have federated identity management, which we talked about, which is connecting one identity provider to another. We talked about identity providers, which are entities that provide identities to cloud providers, service providers. We also have something called a relying party, and that relies on the identity provider to verify the identity and grant resource access to the service provider. And we have this concept of an assertion, which we talked about, which were statements from an identity provider to a relaying party to correctly identify users and attributes. So we have to make sure that we understand this multiple responsibility environment of the cloud providers. We have to understand our user types, the kind of people that are be using our systems. That means our employees, that means our contractors, that means our customers, it means any third-party providers. We have to know what kind of access they will need. The cloud provider has a lot of responsibilities here to manage the internal identities and attributes in their namespace. For direct user access, they need to support federation to simplify this whole process of IAM into some other environments. Now, the cloud customers have a decision to make, determine where they're going to manage their identities. And that's part of your security architecture. Where are you going to do this? Do you do them internally, or do you do them in a cloud provider? And features and functionalities may also give you a lot of information related to that as well. We want to select technologies. We want to select architectures that are going to make IAM easy for us, IAM scale better, be more secure, and ideally integrate easily with the cloud providers. And we want to get around scalability challenges because, manually creating identities in a cloud provider space is just infeasible. So that's why we're talking about ways to automate them. Now, there are, realistically speaking, a couple ways we could kind of do trust relationships with identity providers. I'll draw a couple of them out for you because I really think it's helpful to understand from a complexity perspective. So one architecture realistically could be this. We could be dealing with a couple of cloud providers. So this is cloud provider A. This is cloud provider. Oops, bear with me. This will be cloud provider B. And then we can have over here, we can have cloud provider C. And all these things could be dealing with a central repository or a central IAM environment, like a cloud access security broker. And realistically speaking here, what would happen is every user would have a two-way trust relationship with this cloud access security broker. Now it's centralized. It's pretty easy to control. The alternative could be, we could just bear with me. We could do it any ad hoc method that we wanted. And if we did an ad hoc method, we'd have to make sure everybody has a trust with everybody. Now, with 3, this gets easy, but as we start getting more, it gets fairly complicated with the number of connections. And this would be more the freeform model where anybody who wants to talk to anybody just connects to anybody. This is easier to manage. But, there's multiple ways we can do anything, finding the one that's going to be most effective for us. Whatever we do, we need very strong forms of authentication, authorization, accounting. And whether that be that we're dealing with federated identity access management, something you are, something you have, something you know, and combine them all together. The point is to basically provide a robust environment. Role-based access control, tried and true, policy-based access control, attribute-based access control. And when we really want to get into it, we start getting into context-aware, which is kind of the attribute-based access control with a little more capabilities to it. Instead of looking at just some aspects, it typically has the decision-making ability of these systems to actually use AI to interact in real time. But we have to choose the right system or we won't be secure. Multi-factor authentication, not really an option anymore. Whether we use hard tokens or soft tokens or out-of-band passwords like SMS or biometrics, we should be thinking of something that's going to work. Passwordless authentication is going to simplify things. And realistically speaking, we want to come out of a nice way to do entitlements and rights management, know who our users are, know what their capability are, and we want to document. All right, we are back. So let's see if there's any questions that we can assist you with, because I want to make sure everybody gets as much as they can from this session. In our experience, what are the general best practices when designing a security architecture to reduce the risk in a cloud security environment? So let me describe my view of best practices, and then I will actually answer your question. So, these are health best practices. A person should eat lean proteins. They should eat ample fruits and vegetables. They should use healthy fats such as monounsaturated fatty acids. They should do some resistance training several times a week, do some aerobic training 7 times per week, maintain an optimal weight, and do some mobility training too. That is generic recommendations that work for everyone. When it comes to architecture, the key is to be able to find out what those clients' unique needs are and then create something specific for them. So, what I would do for a military context or somebody that's making a weapon system wouldn't look anything like what I would actually do for someone else. I might use different clouds or have to use very different things. So, best practices, yeah. So, I'll give you best practices. Best practices are to use network security. This means things like firewalls, IDS, IPS systems, packet filters, microsegmentation, various subnets, things like that. I would also tell you to have application security, which means that all the people that are creating the applications make sure their code is checked for vulnerabilities. They have other people review their code. They have things like input validation, input sanitation as part of it, and those types of things from an application security perspective. Now, IAM, in a perfect world, we use the most effective form of IAM for our clients, which is typically some form of authentication with a biometric device. In a perfect world where people have an unlimited amount of money, for example, and we do something that's context aware so it knows where people are. But here's more pragmatically, we have to determine what's the right kind of access control of our client. How do we implement the principle of least privilege? Should we use rollback as access control, attribute-based access control, or context aware? And their budget's going to have a lot to determine that. What are we trying to protect? Are we protecting $1 billion asset versus something else? So kind of think about things like that. So it is going to go everywhere. What is the business needs? What are the business's uptime requirements? Can the business shut down? And if so, how long can the business shut down before there's irreparable damage to the business? I've got some businesses that can be down for 5 minutes every 5 years without somebody dying. And I've got other businesses that can be down for a whole day. The disaster recovery business continuity plans we're going to create are going to be very different. Typically speaking, business continuity plans are how you keep the business going. So if you had a hospital and there was a hurricane, how would you take care of those patients? Could you use generators? What could you do? That's business continuity planning, where the disaster recovery planning is more what goes on site. What are you now, depending upon the amount of time an organization can handle down will determine how many clouds they need, which will impact their cloud security, for example. So there's a lot of things to actually consider what we're doing, and I've only given you 30 or 40% of them. Now, I just mentioned network security, application security, and IAM security, but there's going to be other elements of security that need to, we need to think about risk management, quantifying what we're managed, developing protective strategies. So a lot of it's going to go into it. So the same way I wouldn't prescribe 2 patients the same pill when I go back to practice medicine, which I occasionally do as a volunteer because I love. There's really no recommendations for everyone. And when we get into frameworks and reference architectures that do provide guidance without knowing what the needs are, they're just like saying, everybody in the world, I'm going to give you all the same pill, whether you need it or not. I hope that made sense. But some of the best practices are, key, not let people reach things they can't reach. For example, use the principle of least privilege, mark and classify your data, protect your data, use your data loss, because data security would be something different. But I kind of hope that works. I hope that explains why it's not that easy to just come up with a recommendation. And I'll elaborate. Anybody that just gives you a recommendation like that, chances are it's not someone you actually want to work with. And it's no different than the surgeon that would go to a football stadium and say, everybody in the football stadium, I'm all giving you the surgery. They say, why? Because I'm good at it and everybody should have the surgery. It's that kind of thing. I hope that makes sense. I see, Pablo, you put something in the area about some of these things being difficult to learn. 100% agree with you. The good news is the things that are the hardest to learn are the things that most people won't learn. And when you learn the hardest things that most people won't learn, you have the skills that most people don't have. And that puts you in a new playing field where you're not even competing when you go interview for a job. And, kind of keep that in the back of your mind that, these things are a little tricky. And there's a whole lot of moving parts. And when we think about all the idiosyncrasies of each and every one of these things, and there could be thousands, then when we think about how the engineers are going to implement it, we may have 800 different options. And each option will have its strengths and its weaknesses. And then when we go through and weigh the trade-offs between each one's strengths and weaknesses, that's how we're going to get there. So I am with you. This is tricky stuff, and that's why they pay us well. Because it is tricky stuff and the average person won't go to that experts. But by the time we think about federations and cloud access security brokers and the type of IAM and even how we determine to authenticate someone and we evaluate all those traits, that can be weeks just to determine that in an architecture, because there's a lot of things we might want to do, but will they work for our workflows? What other problems will they cause for the business along the time? So I completely agree with you. So kind of hope that, but the point is all of you can all learn it. It's just a matter of spending the time doing it, watching it 2-3 times, reading the corresponding books, and you can all do anything you absolutely want in life. I mean, anything. I've seen it so many times over. Okay, well, if there are no other questions, we'll get to the next section, and I'll see you back in about 16, 17 minutes. Let's discuss Domain 6 in preparation for the CCSK exam, which is related to security monitoring. And what is security monitoring? What are we talking about here? Security monitoring is really keeping track of all the stuff that's going on in your cloud environment. And we're predominantly going to be talking about logs in our discussion today. But the key here is in the cloud environment, we're going to have a lot of things going on. We're going to have logs coming in from, for example, the network devices, logs coming in from compute, logs coming in from applications themselves, logs coming in from the control plane. And it's going to be really challenging if we're not careful to actually keep track of all of this. So when it comes to modern logging solutions, I want you to think about how much of it we're going to be doing. And AI is going to actually be coming into the system a lot more than you would think. Because if you really think about it, and I just want to briefly talk about what it could look like. Let's say here's your management plane. And your management plane could be your control plane for the cloud provider, where you're adding users, adding virtual machines. The management plane could be components of your routers that are directing traffic through your network, or your control plane, depending upon how that's laid out. So your management plane is going to give you a set of logs. Now, at the same time, the services you also use are going to give you logs. So maybe you're in a cloud provider, and I'll call them service logs, but let's talk about what these things actually could be for a second. So maybe we're using a cloud provider's API gateways, or we're using a serverless something, and that's going to give us generate a set of logs. Now, the devices themselves that we have, this is also going to generate a set of logs. So maybe I'll call these resource logs to be consistent with the way they would use it. And these resource logs can be logs from your virtual machines, configuration change logs on a resource, for example, a database transaction log, an object storage file access log. So we could be talking about those types of resource logs. And of course, we're going to have the cloud tools itself, which are going to generate tools. And these cloud tools could be things related to security posture management, or cloud access security brokers, or other types of things. So all of these things are going to be generating logs. So ultimately, at some point, we'll talk about it. But maybe what we're going to want to do is we're going to take all these logs, and we need to make sure that they can get to some system that's going to be smart enough to make heads or tails of these logs and correlate logs and say, oh, this one thing happened on the management plane caused all these problems, or this thing where someone broke into the system caused all these systems. And we're going to be using, typically speaking, security information and systems for these types of environments. But I want to get back into the content before we talk too much about this, and we'll talk about various things that we can typically do. But understand we're going to be getting a lot of logs, and they're going to be coming from there. So we have to monitor the cloud because it's kind of complex. Each of these clouds have their own management planes. The Google management plane is different than the AWS management plane, which is different than the Azure one, which is different than the Nutanix one, or the OpenStack an organization has. And we have to monitor this stuff to be able to keep our system secure. Now, on the cloud, stuff changes pretty quickly. Somebody can launch an infrastructure as code strip and launch 10,000 servers in about 5 minutes. And things happen constantly in the cloud. New things are deployed rapidly. One of the reasons we like the cloud is its speed and agility. But all these changes can be hard to track. So we have to monitor these things. Now, in the cloud, we have our resources distributed all over the place. So again, that makes it harder. So we have to be monitoring what's going on all over the place. We have to make sure that we're not just adding too much stuff and sprawling to too many workloads, to too many places. It can get fairly complicated. And then we're going to have to monitor that. So we have to be careful. And then we also have to monitor the shared responsibility between us and the providers. We're the cloud service customer, and the provider has to do certain things like keeping the hypervisors up to date on their systems, or keeping their underlying network of routers and switches working. So we're going to have to really deal with some logging and some events. And I really want to talk about the difference. Logs give us detailed records of all activities. And you typically think CRUD: create, read, update, or delete. This kind of information is stored for long-term analysis, anomaly detection, forensics, operational insights. And, that's your logging. Now, your events are something different. Events focus on key changes like create, update, or delete. And they're often tied to security alerts. They may require immediate action within sections. They may need a response. And we can typically take an event and create something called an event-driven architecture in cloud computing, where something happens and then maybe we kick off a function as a service, like a Lambda function, to go remediate it. So there's a slight difference between logs and events, and even though they're very similar. So what is the security posture? Now, the security posture is basically everything that organization is actually doing to keep these systems protected against threats. And logs and posture management are two different things. It's going to take a lot to architect your system way beyond the logs. The logs are going to be able to keep track and see what's going on in your system. And good, strong security posture management needs obviously the right solutions, understanding what you're protecting, but it also takes continuous monitoring to make sure that the configurations in the systems are doing what they're supposed to be doing and they haven't changed. We want to compare ourselves to best practices and good standards. If we're getting alerts, we need to be notified about these alerts quickly so we can do something about them. And we may have to identify and prioritize issues because in most cases, an organization won't have the resources to fix everything. So let's talk about some management plane logs. We could be getting them from, say, AWS, CloudTrail. Azure can give us audit logs, as they would call it. These are going to be the kind of audit logs, or these are going to be the kind of management plane logs we could be getting. Now, again, we're going to get service and application logs. And this could be logs from a load balancer, logs from an API gateway, for example, logs from storage, something, for example, that we might have. And again, I mentioned resource logs, which are going to be related to resource provisioning and changes in the cloud. So data access, data transfers, and of course, we're going to go back and have our cloud native tools. And these cloud native tools are going to help us manage and monitor these systems. And that's going to help us improve our posture. So if we go back to this, remember, we're going to get logs from the management plane. We're going to get these service logs. We're going to get these resource logs, and we're going to get these have these clouds to help us. So let's talk about cloud security posture management. And that's really about monitoring the security so we can improve the security of our environments. And whether that's an infrastructure as a service environment or a platform as a service environment, we need to manage that security. We need to identify misconfigurations, compliance violations, any kind of security risks. And the key here is we want to continuously be monitoring and come up with automated remediations when we can, and compliance reporting, because we're really trying to make sure that everything we do is going to get us to our goals. So we'll talk about some tool categories you may see on your exam. We'll have things called Cloud Workload Protection, Platform Protection, CWPP. And that's going to secure workloads like your containers, your Kubernetes, your serverless functions. And what's going on here is they're going to scan for vulnerabilities, misconfigurations, and provide guidance on what you could do to harden these systems. We will also have data security posture management systems, and that's going to protect sensitive data and ensure compliance with regulations. This will help with things like data discovery, data classification, and help provide encryption policies, enforcement, and access controls. And this is typically applicable to all your environments, your infrastructure as a service, your platform as a service, and even your software as a service. Now, we have to be working with tools for application security posture management, and this is going to manage application security throughout the development lifecycle and the deployment. These tools will enable collaboration between security teams, operations teams, and developers, and it's going to help detect, prioritize, and remediate vulnerabilities before the code would be launched. Now, we also will have tools for cloud infrastructure and entitle management, and that's going to govern access to cloud resources and really enforce that principle of least privilege that we need to do. It will manage permissions for users, applications, and services. We want to have the concept of cloud detection and response, and there'll be more cloud native tools for this that can detect and respond to security threats, and they're going to be using analytics, threat intelligence feeds that are coming out, machine learning to see what's going on. And typically speaking, they'll identify suspicious activity or anomalies or any kind of indicator of response or any kind of compromise. And then we'll have software as a service posture management. And that's really monitoring and securing our SaaS applications, or the software as a service applications. This provides some form of centralized visibility into configurations and compliance with security concerns. And by doing so, we can ensure alignment with regulatory requirements and security policies. The point here is to use these tools to provide some centralized security capabilities, because we're going to have a lot of different cloud services and we need better protection of them. So the key here is we're really looking for things that we need to manage, access management. We could be looking through things like unauthorized API calls or logins without MFA, for example, or maybe someone disabled a function that was supposed to be normal, or they changed an IAM policy. So we really want to be looking at that. We want to be dealing a lot with resource tools and managements, like what happens if somebody adds or changes or updates an object storage bucket in a cloud, or they modify a configuration, or they change an access list. We want to be able to monitor these things and see what's going on. We want to be able to look at those logs and see what's going on, because at the end of the day, if we put this stuff together, that's where we can start analyzing things and understanding. The key to remember is we're going to get a lot of information, and whether you call it logs, whether you call it telemetry, all the stuff that's coming in, you're going to get a lot of information. And we need to constantly collect this information, evaluate this information, and make decisions on this information. So there's going to be a lot of different ways we can collect the information. There'll be several different architectures, and there's not going to be a one-size-fits-all approach. We're going to have to evaluate the client's needs and figure out what's going to be the best after evaluating all trade-offs. But the focus here is to make sure we collect what we need. We're monitoring major architectural changes in the system. Now let's talk about logging in the cloud, log storage. So, in the data center, it's not that much. Storage is cheap in the data center. In the cloud, you start paying for everything. So we have to think about where we store the logs. Do we store them in the cloud? Do we store them externally? So do we store them in both the cloud and on-premise? Do we send them to SIEM systems like I showed you? So we have to think about what we need to do. Now, there are some industries that are regulated where logs need to be stored for years. Other businesses, it doesn't provide that. So we have to look at legal and regulatory requirements and determine how long we need to keep it. Now, if we use the cloud provider storage for our logs, it might be convenient. It really might. If we put it in our own environment, it will have much greater flexibilities, but we may have to pay to get the data in and out of the cloud, depending upon the cloud provider and what they're choosing. When it comes to logs, we often want to come up with a hierarchical approach to it, where we collect them, filter them, analyze, and then figure out what we're talking about. So let me kind of draw that out, what that actually could be for you. Because we're always going to be looking for something that's going to be holistic. So let's say we get logs from a lot of different environments. Let's say we've got a log from a dev team, and we've got another log from the QA people that are doing their testing. Maybe we've got logs from the actual environment, the real environment, the production environment, real environment. All these things are going to generate logs. All of them. So these are all going to be sending logs. So, ultimately at some point, we're going to want to collect these logs someplace, like aggregate them, collect them, what have you. And if all this stuff is giving us logs and we're aggregating or collecting the logs here, it doesn't make any sense not to be able to understand all these logs. So that's why in today's world, SIEM systems are so popular. Because what's really going on is all this stuff. Maybe what if you got 100,000 logs per minute from this environment, and another 10,000 per minute from QA, and another set of logs here? How are you going to correlate them? How are you going to know that somebody made one change in the real environment and it affected 10 other things? No. Unless you can look at the logs, correlate the logs, and make sure that they actually tie into something. So we can do things like log forwarding, like I just showed you, where we put the logs into a logging environment. We centrally aggregate the logs in one place, and then we send it to a SIEM system. So this is a common hierarchical log type architecture that we might be dealing with in the modern world. Now, I want to make it very clear, for SIEM systems to work, for intrusion detection systems, intrusion prevention systems to notify a change in the system and do something about it, they have to be smart. So you'll see a lot of AI in these systems. AI will be doing anomaly detection, and it will look for unusual patterns of traffic and behavior. And it's going to flag these potential threats quickly and notify you about them. And some systems can even block them right then and there. It will threat intelligence handling and hunting, for example. So these AI systems will analyze vast amounts of data from lots of storage, and then they're going to make decisions. So AI is going to be part of our security. We'll use AI to use some automated responses to respond swiftly to security incidents, to kind of minimize delays in threat mitigation. We'll use AI for our supporting team to help them enrich their logs, simulate attacks, patch vulnerabilities. So assume that AI is going to be a pretty significant part of our security strategy. All right, we are back. So let's have some fun. Let's answer some questions. So Chris from my team, in a moment or so, will bring them back. In my experience, what are general best practices for designing a security architecture to reduce risk in a cloud security environment? We actually kind of talked about this one last time, but I'll go back to some generic risks because, we still should talk about it. So, in a perfect world in cloud computing, we use more of a zero trust model because we don't have those hard boundaries that I talked about. So, realistically speaking, that's something we could do. So, sorry, my team put up their own question, but I'll just work with it. We'll go to the next one then. Sorry about that. Mike, can I repeat on the greatest risk of implementation federation? So, if we start thinking about this, the greatest risk in a federation itself is actually going to be what happens to your federation itself. So, for example, bear with me. So, for example, if you federate with someone, which means you trust them, and all of a sudden something happens to them, that's your real issue. And that's the real problem you could potentially deal with a federation for the most part is you're now trusting someone else. And if they're compromised, now you're in trouble. So imagine you're speaking to two different people and you get information from some person and you sell that information to somebody else. That's your job. You're an information broker in a legitimate sort of way. So somebody knows that you're an information broker. You're selling some type of data. Maybe it's a scientific data to another type of scientific company. So you're selling information, but all of a sudden someone realizes you're selling information to a competitor. And what they actually do is they now send someone else to feed you bad information to then sell to your competitor. That would be basically you get bad information in and then you get bad information out. So anytime you federate or agree to trust somebody, if they become compromised, then you become compromised. And it's the same kind of reason why we implement a separation of duties where you don't give one person too much power in high security, because we're always trying to look for where the vulnerability is. So federated things make things a lot easier and reduce complexity, but now you got to trust the other guy or the other provider or guy, whatever you want to call it. So if they get hacked, you get hacked. That's a really great question there, Ella Duffer. And if I get your name wrong, I'm so sorry. So exactly, thank you for that one. And my Chris from behind the scenes, we can go to the next one. And that was actually the first question. Chris. So okay, well, we kind of answered it last one. There was some confusion in the back and here, so we can actually just go to it a second time. I really have no issue. So I talked last time about the architectural principles of why you really need to think it through. But let's talk about things that make sense. So when it comes to things that make sense, zero trust. And the reason zero trust is I showed you how we don't have that lack of perimeters. So assuming that nothing is trustworthy, assuming you're already under attack, it's probably a good thing to do. Now, when we talk about zero trust, we're also talking about multi-factor authentication. Typically speaking, we're talking about micro segmentation. We're typically thinking about much smarter IAM, like context aware. So if Cindy tries to log in from Port St. Lucie on her on Cindy's computer, that's great. But what happens if instead of Cindy being in Port St. Lucie and Cindy stays in Port St. Lucie, if Cindy were to try and log on from Nepal, for example? Now, unless Cindy went to Nepal, I should be concerned that it's not Cindy. So we can give her a different type of challenge and not even allow that Cindy off the network. And if Cindy is a cat who's stuck in my house, Cindy's definitely not going to another place. So we typically want to think about that. So at least those kind of things will make sense. Now, segmentation and networking is part of zero trust, but we always want to use it. Those are things like firewalls, IDS, IPS system, VPN concentrators, those types of things, route filtering and things that go into networking. You always want to do them, and you always can. Now, encryption, I guess you could call that a best practice. So anytime you're sending data over the public internet, encrypt it with either IPsec TLS or both. But also anytime you're moving your data, maybe encrypt that with TLS type encryption. But also when you store your data, you may want to also encrypt that. Now, you may have some super high security environments, the companies that actually want to encrypt the memory as well, not just the data. And that's called confidential computing, but that's probably not your average client. Now, we should be continually monitoring things. So, for example, how often do you monitor logs? All the time. So we should have SIEM systems that are running 24 hours a day, 7 days a week, that are looking at AI, looking at the logs, and if it sees something, doing something to help stop it. Same thing with data loss prevention systems. We should always be keeping data. We should always prepare, for example, to classify our data and secure our data with all types of strategies. We should always think about what is it that we're trying to protect and build the right risk mitigation plan. Things like transferring the risk to an insurance company versus mitigating the risk with a technical control like a firewall, or potentially a physical control like a fence, or an administrative control just not letting people do certain things. So there's lots of ways we can control these factors. So, we can talk about that. Everybody should have a good backup plan, and every organization should build a good disaster recovery and business continuity plan. Every organization from a security perspective should have a very good incident response plan and security policy. And in today's world, people should be AI driven. So they should have firewalls that can adapt using AI. They should be using SIEM systems that can adapt in a way. They should be using IDS, IPS systems that can adapt and things in AI. So we should be looking for devices that can actually adapt. And when it comes to designing how the configurations are done, they probably should come via infrastructure as code, so we don't have any kind of configuration drift. Those are generic things, but it could take a whole lot more to go into how you would actually design it for that organization. But I think we can say those things are good for pretty much everybody. OAuth and SAML are based on a trust model, which assumes that if one entity is authenticated, it remains trustworthy. Is that a risk? Yeah, it's a risk. It absolutely can be a significant risk. So if and when you deal with federated IAM, you need to make sure you truly trust people and they meet the same security specifications you do. So if you need some type of heavy duty security and you require certain levels of availability and performance in, say, tier 4 data centers that everyone has there, and a certain level of security and security processes and security modeling, if you're here at this maturity level and then you deal with someone at this maturity level and you federate with them, they're most likely going to be a vector of attack. So if and when you federate, you have to be sure that you trust the people, and you have to be sure that they've got their gear wired tight, if you will, that they're very good at what they do and they have everything perfected and all their ducks in a row and they are low risk. But yes, 100% agree. And it comes to any business relationships, anytime you connect to a third party service as well. So let's say you're an auto manufacturer and you connect to a tire company. And that way you can exchange information about inventory, supply chains, times where they're going to get there, whatever capacity. So you may have that system, and that's a business opportunity for you because you may need to know how to get these tires to build your cars. But at the same time, now you opened up a connection to an external provider, which now means you've got actual things that need to be protected. And that means you may have to bring the other company up to your standards. And when you can't, severely limit what information you get from them is credible. So if you can't trust the provider, don't federate it with them. Good question, Roger. When it comes to logs, how often should you monitor them? Constantly in real time. So want to have the same systems that are going to take all these aggregated logs and they're going to be running AI on them all the time. And the reason we need the AI to do this is, okay, this change happened here. This caused a change to occur in the network. This caused a change to happen in this application, and now the application is no longer reachable. And sometimes you need that. But think about tracking an attack. Often what happens is something happens on the firewall that nobody noticed because it didn't look like anything happened. And then all of a sudden somebody's in the network and then they did something and you didn't know and it didn't happen. For example, after Delta Airlines had their event, I think it was, or no, after AT&T was hacked, what was it, 60 days or 6 months until they even knew they were hacked? So, and this was a big, amount of information that was stolen. And most companies just don't know for months. They've got these advanced persistence threats. People are actually in the systems. So when these systems are being monitored in real time, the AI which can mine through large amounts of data and say this and this looks suspicious, they could either alert you to it or they can potentially do something, trigger some event in your event-driven architecture that could fix it. So that's what we're typically talking about. Now, there are also log reviews that need to be done by people periodically as well, and scheduled reviews that could be done, say, weekly, for example. But we've got to be very careful with making sure these things are running constantly, and maybe have some people look at them on a daily basis or a weekly basis. But that's really the key. The real-time monitoring is what's going to matter, and how often you would manually look at it would again be what your security needs would be, and how much you could trust the AI systems, and how much you need to go check in and second and third guess them. I really like these questions out elaborate. Okay, well, I don't see any other questions right now, which is fine by me. If the questions pop in, we look forward to answering them. So I hope everybody's having some fun learning a lot about cybersecurity. And I know some of this IAM gets a little icky and it gets from time to time, but it is very important. So I hope everybody learned a lot with it. So we'll get back to the content. If you're having a good time, hit the like button. I'm reminding everyone that tomorrow between 11 and 1, we're going to talk about how to become a security architect. And you can join us on the free webinar. It's usually 1 to 3, but tomorrow is going to be 11 to 1. So come and join us. And if you didn't catch it live and you want to take this webinar later, come join us. The links will always be in the description of this video, as well as the chat box. So, Chris, let's get back to the content. Let's start talking more cybersecurity and give me a hashtag CCSK. Now we're going to get to domain 7 for the Certificate of Cloud Security Knowledge CCSK exam. And we're going to be discussing infrastructure and networking. And at the basic introduction, the core of cloud computing, specifically infrastructure as a service, is really a rental data center, that virtual data center that we showed you in the beginning of this video series. So we have to figure out a way to secure that infrastructure. And what we're going to talk about here is some basic cloud infrastructure security, some very basic networking fundamentals, a little bit about security architecture and infrastructure as code, a little bit because it's a very entry-level exam, and emerging trends, zero trust and secure access, secure edge. And we'll have some fun with this. So that's what we're going to be talking about in this section. Now, the objectives in this domain are really for you to get an understanding of how to secure the cloud infrastructures, to understand the fundamentals of networking, to learn a little bit about container networking, to overall understand how to strengthen the security posture. Now, the key here that we have to remember is customers must design their systems on top of the cloud systems. It's not automatically secure because you just decided to move to the cloud. So we have to understand at all times that cloud customers are responsible for the secure design of their systems. And we also have to remember the cloud provider is responsible for the stuff that they own, the physical infrastructure, the routers, the switches, the physical load balancers, if you will, the wide area connections, their hypervisors, those kinds of things. So one of the ways we enhance security is by segregating things. So what does segregating things mean? Architecturally, I'll show you an option. if we had a switch, let's say we actually had a typical layer 2 switch that you would have in, say, a data center, and the switch had 2 VLANs in it, and this was VLAN 1, for example, which is called the virtual LAN, and we'll call this VLAN 1, and then we'll call the other one VLAN 2. Realistically speaking, in this switch, the users in VLAN 2 can talk to each other. The users in VLAN 1 can talk to each other, but VLAN 1 and VLAN 2 can't talk to each other. So even though we're in the same device, what we're actually dealing with is the ability to segregate the users. Excuse me. So that's one type of segregation. Now, we could do the same thing in the cloud provider. We could change a VLAN if we wanted to a different subnet. We could change it to a different virtual private cloud or a different virtual private data center, if you will. And again, our systems are separated, and then we could determine how we routing and other things later. So that's segregation of resources. The next way we secure our resources by not letting people use them that don't need to use them. So that's really enforcing our IAM and our principles of least privilege. And it also involves using secure configurations for our systems and secure communications to other systems, because if we're weak configurations and there's holes in our security posture, an attacker can easily exploit those. So this is what we're talking about. Now, it's not just about access lists and IAM. There's a lot of things we need to do. We need to understand that everything we do needs to be secure. So if you boot up a computer, for example, the first time, that computer is not secure. Most servers, most computers, they come up with all the features and functionalities installed for a reason. It makes it easy on you to install things when you need them to use it. If these packages weren't part of your deployment, these systems would be much more challenging to use. The problem is these systems, because they support so many different things, can easily be hacked. So what we have to do is harden our operating systems, harden our virtual machines, make everything harder. So for example, on the operating system on a virtual machine, we may remove unnecessary unnecessary packages. We may be removing closing ports on that system. We may be patching it to a certain level, in addition to endpoint protection that we might put. Same thing for containers. We want to make sure that our containers are hardened, the code inside's them good, and we're using all the security that we can for our containers. Same thing for our storage. We don't want to be sloppy with our storage. We want to know what kind of data we have and provide the right data protections that we need to have, and the right data policies, and the right data hiding techniques, and the right kinds of encryption. Same thing on our networking. We want our networks talking to who they're supposed to talk to, with the correct configurations, with the right protocols enabled, and the right route sharing, and the right access control list, and many other things to protect our environment from danger. Now, all that's great, but we still need some kind of continuous monitoring and some guardrails that are going to be there. So we have the ability to protect the way the configurations are going to be there. For example, AWS config rules or Azure policies. We can enable logging and monitoring for security events, and we can even in some cases set up auto remediations with infrastructure as code. For example, somehow somebody sets a file that they just put in object storage, so I guess it's an object, into AWS S3. They accidentally set the permission to public, big mistake, and an AWS Lambda function in an event-driven manner can kick off and remediate that by changing the permissions to private or instead of public. So these kind of things together are going to go into that security policy. And remember, that shared security model. The cloud provider themselves handles their infrastructure, but you're responsible for your stuff. So the cloud provider is responsible for their facilities, like the physical security, making sure people can't come in, who can access the physical surveillance in the physical facilities, what have you. They're responsible for their employees, screening them, background checking them, managing them, and making sure their employees don't do things they shouldn't do. They're responsible for their physical hardware, whether that be a server, a router, a switch, a firewall, or a storage area and network device, or a RAID array. The virtualization layers, meaning the hypervisors for the virtual machines and any kind of other virtualization they have, like application virtualization they're running. The management plane were basically that website, like the AWS control panel that you could go to. They have to keep that secure, because if that gets hacked, you got a problem as well, because it knocks down the control plane. And any kind of platform as a service and software as a service, they're responsible for that. But everything that you use on top of that, that is yours. So you still have a lot of work to do. So we have to find a way that our systems can be resilient. So the ability for something to break and our systems can still work. And we have a couple ways that we can deal with this. And in the context of cloud providers, we typically have something called an availability zone, and then we have a region. And I'm going to draw this out for you. I want to make it clear to everyone. And this, for the most part, is almost every cloud provider. So what you'll see we have this concept of a large geographic area. Let's say this is the US. Now, the US could actually, let me figure out a better way to put it. Let's say we have the US. The US could be considered to be a region, and if we wanted, inside of the United States, we could have a whole bunch of data centers, and they would be called availability zones in general. And most of the cloud providers use a terminology like this. So what you'll see is you'll have the big giant area, which is called a region, and then you'll have a data center inside of the region called an availability zone. So when it comes to enhancing the levels of resiliency and fault tolerance, we have one option. The first option is if we're only in one of these availability zones and the availability zone goes down, because data centers if it went down, then we'd have a problem. So what at the entry level of higher resiliency, higher availability systems, what a company could do is they could put some of their systems in 2 of these different data centers in a single region in a cloud provider. Now, the weakness is if anything happens to this region, all these users could potentially be down, which is not a good situation. So the alternative that was initially suggested by the cloud providers, which in most cases does not make sense from a high availability perspective, was here, if you need high availability, use 2 data centers in 2 different geographic areas. And while this isn't horrible, if you really think about this, if anything happens to the network that were somehow to take both of these regions down, for example, you lost the whole cloud. So that's not a good situation. If the cloud provider has a DDoS event, a hacking event, they lose their control plane, all this is falling apart. So it's not really an optimal solution to go something like this. So what people could do is they could say, well, here's 2 alternatives and that they could do. So alternative 1, if they really wanted high availability, would be, let's say this was AWS and this was Azure. What someone could really do is they could put systems into 2 data centers, 50% by the way, so it doesn't have to cost more, but put 50% of the eggs in the AWS basket and the other 50% in the Azure basket. Put both of these systems, meaning they're going to be auto-scaling, and I'll explain that in a second, which I'm sure I typed wrong. Auto-scaling on both clouds. And let's say it's only web applications. It's not, but let's just say it's only web applications. What we could do is we could have DNS, for example, in this particular environment. We'd have DNS here, and DNS would normally send, we could say 50-50 traffic. We could send 50% of the traffic from DNS to Cloud 1, 50% of the traffic from DNS to Cloud 2. Now, we'll also put these cloud systems in auto-scaling, and what auto-scaling will do is it will monitor the utilization of these systems and whatever we tell it to monitor. And all of a sudden, if we say when the CPU of a web server hits 80%, add an extra web server, create one on demand, these cloud systems can scale out and add capacity very easily. So if it was a web application that we we had two clouds for. Instead of paying for 100% of the systems in, say, AWS, we pay for 50% in AWS and 50% in Azure, and that way it doesn't cost much more. And then we would use DNS, and DNS would do health checks back and forth. And under normal circumstances, DNS would say 50% to AWS, and DNS would send 50% to Azure. And all of us, and what happens, they run these health checks. So for example, DNS will say, AWS, are you there? AWS will say, of course I'm here. I'm happy. It's a good day. DNS will ask AWS, are you there? It'll respond, I'm happy. DNS will ask Azure, are you there? It'll respond that I'm happy. DNS will ask AWS, are you there? It'll say yes. DNS will ask Azure, are you there? Now, out of nowhere, when DNS is doing a health check on, let's say, AWS, it doesn't respond. Are you there, AWS? No response. DNS asks AWS, are you there? No response. DNS asks AWS, are you there? It's missed 3 or 4 health checks, and then DNS says AWS is down for right now. So what happens is DNS will redirect all traffic to the Azure systems, and the Azure systems all of a sudden are now getting bidding on 100% of the traffic, and they're going to say, we need extra capacity, and they're going to scale out. So what'll happen is half of the capacity will easily be taken, and it may take 45 minutes to get the full capacity of everything, worst case scenario, but the systems are up and operational. Now, this could also be done in 2 data centers per 2 cloud providers or 3 cloud providers. There's a lot of ways of increasing the resilience of our environment. But these are typically the ways we can do that inside of cloud computing. Now, the key of cloud computing, as I mentioned it from the first element that we were here, is that what it really is that we're dealing with is virtual data centers. It's all about virtual data centers. Virtual data center, virtual data center, virtual data center. And what a data center is comprised of: power, cooling, network stuff, and server and storage stuff for the most part. So software-defined networking creates virtual networking, and it basically separates the control plane and the data plane from networking. Now, what the heck does that mean? So I'm going to draw that out for you too. So in a traditional environment with real and regular hard official networking like it used to be, and it still is in many cases for internet service provider routing, what we have is routers. And the routers are connected to each other via wide area network links or local area network links based upon what they have it. The routers might be connected to switches, or they'll have subnets off of the router. For example, that's an Ethernet segment. I'll draw another Ethernet segment on this end. And what we would do in order for, let's say, this router to know how to reach this subnet, the routers would run a routing protocol on them. And let's say it was OSPF that was the routing protocol that all the routers were using. The routers would use this routing protocol to talk to each other to know how to reach each other's routes. So, and the way this actually would work is, so bear with me, apologies for that. So let's say over here we've got a web server, and the web server's IP address is 192.168.1.16.68/24. So what'll happen is a host on this segment will say, I want to reach the web server 192.168.16.64. So the host will look in its routing table, and the host will typically have a default route, which says, if you don't know where to go to my router. That's typically speaking. It'll send an ARP to get the MAC address of the router if it's on Ethernet. Now, as soon as the packet gets to the router, what the router is going to do is it's going to look in its routing table, which was created by OSPF, and it's going to say, do I have a path to it? And if it does, the router will forward it to the next link. If it doesn't have a path to it, the router will drop it. So now the packet's sent to the next router. The router looks in its routing table. Do I have a route to the next link? It says yes. The routes were built by OSPF. It forwards the router. Now, basically speaking, the packet makes it to the server. So if you notice, the routers had the intelligence of how to forward the packet here, and they were doing the forwarding. So that's standard networking. Now, the difference between that and software-defined networking is the software-defined networking, or the control plane, the thing that teaches the things how to make the decision, is separated from these devices. So these devices tend to be able to do the work, and this thing over here is controlling it. And there's lots of reasons we might want to use this. For example, imagine driving down a highway, and the highways are basically just, the roads that are there, and your GPS is there, and they statically knew it. But in this case, the SDN is like a satellite in the sky, and it can tell you, avoid this route, avoid this path, avoid this path. So we can actually create better performance. But we also, in this point, if all the intelligence is here, we can use much cheaper networking technology here, something that just has to do the work or the forwarding and have all the intelligence here. So in cloud computing, everything we're going to be dealing with is some flavor of software-defined networking or network function virtualization, where we're going to be creating virtual networks inside of the environment. So that's the key to remember. These are logical networks. These are logical virtualized data centers, and that's what we're really talking about. So when we're dealing with any kind of software-defined network, what we did is, you saw how the router had the OSPF on it, and it also had the forwarding on it, but now we separated it. So we decoupled our environments. Now this is very flexible. And why is this so flexible? Well, it makes it very easy for someone to push a configuration to this SDN thing and have that pushed to the routers, as opposed to manually configuring these routers. So they can programmatically make changes in here. And even in today's world, in certain circumstances, especially virtual networks, and infrastructure as a code script could build the entire virtual data center, meaning the network and all the virtual routers, switches, and all your IP subnets. And it can actually put the servers there all at the same time. So this decoupling, the software-based, and it minimizes the needs that we need for really strong networking people, because networking is very complicated. So when we get to the cloud, we're going to have a virtual network. The AWS VPC, Virtual Private Cloud, the Azure VNet, or virtual network. These are logically separated networks where you can create your own subnets in them, and where you can segment your networks, but it's your virtual network. So subnets, and there's if you need, there's intro to subnetting videos on this YouTube channel. Please check them out. But subnets are components of various IP networks. And in networking, what we do is we segment our networks and subnet them for efficient use of IP address space, but also to protect them. For example, in this particular environment, let me draw two different subnets, and I'll show you how we could create a boundary. So this subnet could be 192.168.1.0/24. We can have an additional subnet that's 2.0/24. Now, if they're logically separated, and we haven't, if they're logically separated and there's no routing between them, they won't be able to talk to each other. But we can also put an access list on them as well at a subnet boundary. For example, if we didn't want anyone from the 192.168.2.0 domain to enter, what we could realistically do is we could do a deny 192.16. We could deny source address 192.168.2.0/24. And at that point, if we did this, the routers, or the logical router, would say any traffic coming from this subnet to this subnet can't be there. So we're logically using subnets for efficient IP address utilization, and that's more for the network engineers. If you'd like to know more about that, there's a free CCNA certification on this YouTube channel that you're more than welcome to go to. There are also free information on BGP as well, and there's a lot of information on networking, so go check it out. But what we're talking here about, we're using subnets for security purposes, since this is a security exam. We got into some networking fun, so I'm sure there's questions here. So let's have fun. If we have to get a little geeky here, we'll get a little geeky here. As a reminder, if you just joined us, we have a completely free ebook set of cheat sheets that goes along with what we're teaching here. Make sure you sign up for one and use that as you study throughout the exam, along with this video course. So, and tomorrow we will have a free architect webinar, how to become a security architect, from 11 to 1. So hope to see some of you in the architecture webinar. We can talk. You can ask questions. You want to see if why you're not getting called back from recruiters. You want me to check your LinkedIn profile. Happy to look at it real quick after the webinar. So you want to ask me if you want to think you're ready for an interview for, say, a security architect. I'll ask you 2 or 3 questions and I'll determine your level of competency and I'll tell you what you need to learn. And I'm happy to do that. And it's all free. We run these webinars once a week. We want to make sure you get a great architecture career. This week, security architect. Next week will be cloud architect, enterprise architect, AI architect, or other architects that we train. But hope to see you there. Chris, let's see if we have any questions. Ngozi, does that mean that if you're using software-defined networking, you won't need an interior gateway protocol such as OSPF or intermediate systems? Not exactly. So what's going on is we're still going to have to set up the routers. And when we set up the routers, we still have to build the underlying infrastructure. And the 2 routers won't be able to talk to each other without an underlying interior gateway protocol. But we're actually making the forwarding decisions and building an overlay network on top of that underlying network. So in order to create this overlay network as a rule, you have to have the baseline network to actually go. So yeah, you still need the interior gateway protocols to make this work. Just like even if you're passing routes with BGP, for your IBGP peering, typically inside of a domain, you typically need an interior gateway protocol to manage your BGP peers being able to reach each other inside of your autonomous system, even though it's IBGP that's exchanging the internet routing, if you're familiar with what I mean. Great question. Well, I don't see any others. I'll give you all about 30 seconds to see if you have any more questions. If you have questions, we'll happily address them. And if you don't, we're happy to get back to this. We're talking about networking here and security, and these are all my favorite things. So always happy to get back to it. I just want to make sure everybody has what they need. If you are having a good time in this CCSK Certificate of Cloud Security Knowledge Training course, please give this video a like. Again, this is preparing you for the CCSK V5 exam for the CCSK certification. Well, I don't see any questions coming in, so give me a hashtag CCSK so that I know you're awake, you're alert, you're oriented, you're having a good time. And then, Chris, let's get back to the training materials. Now, let's talk about the subnets a little more. As I talked about, we can use subnets for isolation, but we're also going to have subnets that are used in the private address space and subnets that are in the public address space. And let's talk about the difference. Inside of an organization, organizations will use private IP addresses. These private IP addresses are not globally routable. They will not be reachable for the entire world. We're using private addresses internally partially because of that, but mostly because we don't have sufficient IP addresses in IPv4. So we typically use the private IP addresses that are specified in RFC 1918, which is the 10.0.0/8. It is the 172.16.0.0/12, and it is the 192.168.0.0/16 address space that's typically reserved for private IP addresses. So they're what we typically use for IP addressing internally. If we were to use IPv6, we don't have this addressing problem. So when we have public subnets in the cloud, it's for things that we need to be reachable from the internet. So for example, if we have a public subnet and we have meaning IP addresses in a public subnet, and we have a connection to the internet, like an internet gateway or a router that connects us to the internet or something like this, and we have this, then anything in that public subnet is reachable. So this is where we're going to need a whole heck of a lot of security for anything that needs to be here. And that's why we typically create a demilitarized zone and put things that need to be in the internet in those demilitarized zones outside of our strong perimeter where our internal systems will be that have private IP addresses. Now, if we have things with private IP addresses that need to go to the internet, what we typically do is we use some form of network address translation, and I can show you what that is very rapidly. So let's say this is a private subnet. Which means users have a private IP address, and here's the internet, and here's the internet. And then here's something on the public internet, like a web server that we want to go to, that's sitting here on the internet. What'll have to happen is we'll have to translate to the outside world these private IP addresses into something public they can use. So what we'll typically do is we will have the private subnet. They will go through their firewall. The firewall will typically do something called network address translation, where it will take their internal IP address and translate it into something public so that they can reach the internet. The internet traffic will reach the internet with the public IP address that's been used. It'll go through the internet. It'll hit the NAT device, which will then translate it back into the original IP address. So we can do static NAT, where we take one address and always translate it into another address. Or what we typically use in this application is something called network address translation or port address translation, where we translate many addresses into a single address, economizing on IP address space. So that's something that you'll be doing. You're also going to be dealing with route tables. So a route table will tell a router how to go. I'll draw one out for you to make it easy. So the routers, and regardless of where they're coming from, they need some form of knowing where to go. And even though these networks are created virtually, we may need a route table. So the route table would basically be a little database that the routers actually build to know where to send their traffic. So let's have a little fun with this. Let's build a little mini network over here. I always like building little mini networks. And we'll have some fun with it. We'll use some wacky, grossly obvious IP addressing to make it pretty clear where all these subnets are going to be. So let's say over here, this subnet's going to be a 192.168.1.0/24. And now we've got this next subnet over here. And this subnet is 10. Oops, let's make this a little wider. And this is 10.0.0.0/30, normal wide area network link. And I'm going to use a little arrow to point to which subnet we're talking about. That's that one for that link. Meaning one. And then what we'll have here is we'll need another subnet for the next link, which will be the .4 we could use as the next subnet. And by that, I mean this address could be 10.0.0.5, and this could be 10.0.0.6, with this being the network or subnet address, and the 10.0.0.7 being the broadcast address. And if this is a little too academic and geeky on the subnetting, and you want to know more, and you probably do need to know more in security, feel free to, again, go back to our subnetting webinars that are on this channel. We've spent 4 to 6 hours on it. We've got a free CCNA bootcamp for you to go through to learn a lot more about networking, and networking and security are quite closely related. So let's change this to another IP address in a different subnet. Let's change this to 172.16.1.0. Let's change this from a /30 to a /24. So it could be a LAN segment that has a fair number of servers or users on it. The routes have to build a map that says where do they send their traffic. So basically what happens is routers have interfaces and they have ports. So if we were to say on this port, if this port is ETH0, and by this port I mean this thing right over here that's connecting it to the network. And let's say the router has another port on it called ETH1, which is, and when I say ETH1, I'm referring to this interface. What the routers will do is they will build a map, because if you don't have a route to something in your routing table, you'll never be able to reach it. So what we're dealing with is this router is going to build a little map, and it's going to say, for example, we'll make a routing table, and it'll say, in order to reach 192.168.1.0, use ETH0. which means if it's got something destined to use 192.168.1.0/24, go out that port, and then you're going to see a routing table entry, and it'll look like that. And your cloud providers will have something that looks like this as well. You'll also see in the routing tables, you'll see something like this. And it's also going to be ETH0. It might show something like directly connected, but what have you. And then what you'll also see is let's get this subnet. And you'll see why we're building it this way. And then it'll say to reach 10.0.0.4, use this interface. And then it'll also even say on this router to reach this subnet, use this interface, ETH1. And that's what'll happen. A packet will go to the router. The router will look in its routing and say, well, do I have a route to it? Yes, 172.16.1.0, go that way. Drop it off at this next hop IP address. Or it can say, oh, I want to reach 192.168.1.0. Oops, use ETH0, and it goes that way. So these are the way the routers and routing tables work. Now, if there's a missing route, if there's no route to this 172.16.1.0, and the packet's at this router, and there's no route to this, or no route to this if you wanted to reach this, the router will just drop it. And it dies right there. So, we have this concept in routing of if you don't have a route to it, you can't hack it. So we want to be careful. Now, we have another thing, typically speaking. We've got what's called security groups and many of the cloud providers. And what is a security group? A security group is basically a host-based firewall. So we'll draw one out. So if this is a virtual machine we had in, say, AWS, they give us the ability to put a security group on this, which basically says, which is basically a stateful firewall that we would say this kind of traffic is allowed in, and everything else is denied. So if it was a web server, the security group on this virtual machine would be to allow maybe TCP port 443 in and nothing else, or maybe port 80 and port 443 TCP both, and it blocks everything in. And of course, it's stateful, so it'll be monitoring the packet going into the server, and it will remember that the packet was entered to the server and the server responded, so it will automatically add it out. So when we're dealing with stateful firewalls, because they remember the state of traffic, we only have to apply it in one direction. Where if it was more of an access control list, we would have to apply it in both directions. So we're also going to have some form of a cloud network access control list. And all an access control list is a simple packet filter where we can use to protect a subnet. So what does this mean? We've got two subnets over here. They're separate subnets. Subnet 1. We've got subnet 2. And what we have the ability to do is tell subnet 2, don't allow subnet 1 in an access list. Now, granted, we'll list the subnet, but if this is the case, if subnet 1 wants to talk to subnet 2, it can. So what we're going to do is we're only going to allow systems to talk to each other. So if subnet 1 needs to talk to subnet 2, we allow it on the ACO. But if subnet 1 doesn't need to talk to subnet 4, we can use access control lists to block their communication. Because if they don't need to speak to each other, why would we let a hacker get on subnet 4 and be able to hack subnet 1? So we use access control lists for this, typically speaking. Now, other things we're going to have on the cloud networking wise, are going to be things like load balancers. So in a physical data center, we have physical load balancers that distribute load between servers. In the cloud, we have virtual load balancers. So what's a load balancer really doing? So let's say we had one virtual machine, and this virtual machine had 64 physical cores. And a terabyte of DRAM, and this was our web server. Everything's running great. This can handle all of our web stuff, and all of a sudden the server crashes, the power supply goes, and all of a sudden I have no server. This, not a good situation, because I had a single point of failure. So what we can do is we can use load balancers. So instead of a 64-core server, maybe I use a 16-core server instead, a 16-core server. And instead of having a terabyte of RAM, maybe I have 256 of the gigabytes instead. And maybe I have 4 of these systems. And what I can do in the load balancers are what's called logical devices, so they don't typically break on a cloud provider. And now I've got a load balancer. And what the load balancer will do is it will distribute the load across these, and we can set a policy on how it distributes it. And if out of nowhere one of these virtual machine crashes, the load balancer knows not to send the traffic there, and we still have some availability of the system. And if we wanted to, we could then auto scale and create a new web server to make it more self-healing. So there's a lot what we can do with load balancers. We typically have 2 kinds of load balancers, and they're going to be network load balancers and application load balancers. And I can tell you the difference right now. So the network load balancer is going to be fast. And the reason it's going to be fast is it's going to look for basic things. It's very basic. It's going to look at things like the TCP header, source, destination, protocol, and port numbers. So it's typically layer 4 that it's operating out of the OSI model. And this is great when you need speed. So imagine going between virtual firewalls where you need max performance. You use network load balancers because they are fast. So great opportunity for fast. They are fast because they're not doing a lot. And how fast could you do basic math? 2, 4, 6, 8, 10, 12, 14, 16, 18, 12, whatever. But how fast could you do a calculus derivative in your head? So the next phase of what we have is we typically have what load balancer wise, we have something called an application load balancer. Now these are slow because they're looking at layer 7. They're very intelligent. And these are typically good for looking deep into what's being done. So maybe we've got some microservices and they're little small things and they need to be intelligently routed. And we've got a lot of them. So we might use application load balancers for this, which is a common environment. And we'll have these on all clouds for these types of reasons. So that's going to be part of your virtual networking. Is going to be some flavor of a load balancing service. It can enable redundancy in certain ways. If we had a load balancer with auto scaling, if a DDoS attack came in requesting 100,000 hits a minute, and we can only do 80,000, potentially auto scaling could enable us to get past that constraint while we find the problem. So load balancers help with a lot of availability and performance. Now, the next thing we're going to talk about is something called an internet gateway. Now, a gateway is another word for a router. So an internet gateway is just a router that connects to the internet. So in the data center, it would have been a real router. In the cloud, we've got, let's say, our VPC, our VNet, or whatever we have. And then we have all of a sudden a little router that connects us to the internet. In this case, it's called an internet gateway. And the internet gateway connects us to the internet. Oops. This is what happens when you do too much drawing and doodling in PowerPoint on your computer when you're trying to give a presentation. Anyway, we will also have something called endpoints. And endpoints will provide a way for you to access various services inside of your cloud provider over the cloud provider's network without going over the internet. So here's what I mean by this. Let's say you've got your VPC. And you wanted to connect to something that's on the provider's network, say AWS S3. There'd really be 2 ways you could do it. And I want to show you the ridiculous way, and then I'm going to show you the smart way, just so you see it. The ridiculous way would be to send your traffic out the internet, cross your traffic on the internet, which is the scariest place in the world. The internet's not secure like a private network. Then encrypt that traffic, and then take it out of the internet and bring it back into AWS. Now, depending upon whether they're charging you in and out for the internet based upon what year it is, that could have gotten pretty expensive. But more importantly, why would you want to do this when the VPC is sitting in the AWS network and AWS owns the AWS S3, and all you can do is connect to this little thing called an endpoint. And now you're connecting to your AWS service over the AWS network, and the AWS network can give you good guaranteed performance compared to the internet, which is best effort, because this is controlled by AWS and this is controlled by thousands and thousands and millions of people. So there's no centralized control of the real internet here. Internet is best effort. This can be guaranteed as higher performance. So that's now, if you really think about this, there is a lot of things that we're talking about, and it all goes back to that virtual network. So the cloud providers have broad network access. They've got that management plane, the control plane. They've got servers. They've got storage area networks. They've got load balancers. It's all software-based, but underlying it is the physical thing. Now, we can use all kinds of networking connections to connect to the cloud. We can use VPNs. We can use private lines. We can software-defined WAN. So pretty much what we're dealing with cloud networking is a basic version of what we used to do. So keep that in the back of your mind. Now, we can do all this in a private data center. All of it. We can do it all on the cloud, but we just have to know what we're doing in order to be secure. Now, all the major cloud providers are going to offer some flavor of a service because they're all offering the same thing. Outsourced data centers. So instead of build your own, they build this super big monster one and you rent space in it just like a hotel. So we have to understand the main components, and then we can understand the provider's variances for it. Now, the cloud providers have firewalls that you can use. Amazon has an Amazon network firewall. Azure has an Azure firewall. And they're going to be built into the cloud platform, so you don't have to run a server to do it. They're going to be very simplified in terms of their management compared to virtual appliances, but they're going to be weak in their performance compared to some of the more industrial solutions that have that behavioral analysis that can really look and see things that are going on. Now, with the cloud providers, we can go to the marketplaces and we can get virtual appliances. And these are going to be big, heavy-duty, industrial-grade firewalls and industrial-grade security systems that we can run on virtual machine. We'll typically use a load balancer with them. We'll deploy them in a high availability environment. And this is what you're going to see for big enterprises because this is the good stuff. But it's more complexity. It's more work because you have to get them and you have to configure them and know how to use them. So we lose some, not much, but some of the simplicity we would get with the cloud providers' firewalls, but we might get a lot better security. Because the cloud providers are in 1,000,001 businesses. The people that make these security devices, that's their business, and that's all their focus is. We can also use web application firewalls. Now, they could come from the cloud provider and be very basic. We can get them from major security companies. And they tend to be more cloud native, and they tend to be looking for more web attacks like SQL injection attacks, cross-site scripting, those types of things. Now, we always want to be monitoring what's going on inside of our system. So in the data center, we've always had this concept, at least if it was Cisco devices, of Cisco NetFlow. And that would capture, the traffic on, and it would tell us basically who's speaking to whom and that kind of thing. And with the cloud providers, because it's a virtual network, they give us something, and they're typically called flow logs. For example, AWS has VPC flow logs, and it just captures network traffic. Now, we're going to get our logs from our DNS servers, and we should be looking at them. It might give us some visibility into traffic patterns coming in, but DNS logs will be coming from our DNS servers. And the key here to remember, as we talked all about it a little before, is dealing with this many logs is going to be challenging because we're dealing with a lot of logs. So we're probably going to need at some point SIEM system. I'm going to briefly touch on infrastructure as code. So one of the things people like about cloud, and this can be a private cloud like a Nutanix cloud or an OpenStack cloud, or it can be a public cloud like AWS, Azure, or Google, is the speed of deploying things. See, it used to be servers we had to manually rack and stack. And because of this, we had a bunch of sysadmins, a bunch of help desk technicians, people installed operating systems. These were the jobs people used to get as their first jobs. In today's world, we can now have one DevOps engineer write an infrastructure as code script that could literally launch something that would normally have taken a year in a matter of seconds to build out with a team of people. So because of this, when it comes to jobs, obviously prepare for the bigger jobs that are much more strategic in nature, people-oriented in nature, and there's plenty of jobs over there. But those entry-level jobs, that's why there's less of them, so, which is no big deal. Just get a more senior job, prepare for it. But keep that in the back of your mind. It's predominantly because of infrastructure as code. The ability to write a script like a Terraform script, or an AWS CloudFormation script, and just literally launch an entire environment immediately. Change an entire environment, update the script, and push it all out very quickly. So, we have the ability of infrastructure as code. NIST has a definition for it, the NIST SP 800-172, and it says the ability to manage and provision infrastructure with machine-readable config files, not manual hardware or interactive tools. But the point is we can deploy so much so fast, and it's all occurring via this infrastructure as code script. Now we can do checks on the configuration already. We can check that configuration against security standards at every change, which is great. This helps provide a consistent security posture, eliminate human error, maintain uniform configurations. We can roll back from a change very rapidly. And of course, it also helps the organization cut their staffing costs. Now, this has been adopted on every cloud provider. Many of them have their own tools, but many, in fact, organizations mandate infrastructure as code for the engineers that build these systems because they don't want variations between systems. A little bit of zero trust for cloud infrastructure. So cloud infrastructure is not like traditional infrastructure. It has a lot of weaknesses in it that we have to deal with. And what do I mean by that? Well, let me show you. I kind of showed you earlier in the beginning, but here is normal infrastructure. Normal infrastructure is in here. This is hard. This is protected. This is internal. So, in here, we've got our users. They might be segmented into VLANs. We may have ACLs in between VLAN subnets from the IP perspective. We've got QoS over here and all kinds of cool things that we're doing so we can prioritize traffic over another, which is going to be important sometimes if, for example, you get a worm or a virus hits your system, you want your traffic to go above the worm or virus traffic. We can do anything we wanted, including firewall one subnet off. But we've got a lot of opportunities. But here's the key to remember: in this environment, of course, inside of our networks, we've always had our IAM. But in a normal environment, here's the internet. Here's your firewalls. You might have a couple layers of firewalls. Anything that needs to be reachable on the internet sits out here in a DMZ. So nothing's getting in here for the most part. That's why we always had such strong, we protect these internal areas, but this was easier to protect. I'm going to put the DMZ over on this side. Now, if we look at the cloud provider, if you really think about it, here's your VPC. Here's your virtual data center. This subnet, by the way, is public and attached to the internet. If we do it this way. And then this subnet over here is your private internal stuff. And the internet's over here. So this is a little bit scary. And what changed here is we had these big, strong, powerful boundaries. And now it's all this virtual stuff. These boundaries are a little weaker. So, and we had such incredible network control in the data center, and we lose that here. So we need to move on to a better paradigm, and that's the drivers behind zero. The change dramatically going from the traditional environment to the cloud environment. We lost these boundaries. So now we need some means to constantly check and constantly make sure we're there. And that's the concept of zero trust. Trust, but verify. So in a zero trust network architecture, only verified devices are even going to get access, verified users. So you can't get access until you authenticate to the system. So this is going to be here. We're also going to we may also have a software-defined perimeter, and that's going to conceal the resources we have from anybody that's unauthorized to have it. And we can get fairly customized. with zero trust. And, there's some core features to this concept of a software defined perimeter. What we're doing is we're creating a dark network that's effectively invisible to unauthorized users and devices. And it's kind of like a default blackout approach where basically we're going to make the network inaccessible unless you're authenticated to the system. And then we're going to use an identity-centric approach and microsegmentation to limit movement anytime we can. So we'll do any kind of microsegmentation things that we can still do. And now we're going to we're going to check every request that you do against the IAM system to make sure you can do it. So we typically have a software-defined perimeter client, and this is going to be installed on the user's device. It's going to connect to the system like a laptop, a tablet, or a smartphone. And that's going to initiate a connection with the SDP controller or the software-defined perimeter controller. And that's going to be like your policy decision maker. And it will determine access based upon attributes, whatever they may be. And it'll communicate that with the software-defined perimeter gateway. And the gateway is going to provide your temporary access to protected resources. And that's how these things typically work. So the key here is if we're using the zero trust network access, this kind of SASE type software-defined perimeter things that we're really talking about, we're kind of using it to replace a traditional VPN. And in a traditional VPN, we have an IPsec tunnel that comes up to a specific device, to a particular VPN concentrator in a certain place. And there's times where we still want to use that. If we're using more of the zero trust network access kind of SASE type environments, what we're really doing, we're replacing these traditional VPNs. We're using something application specific controls. We're going to be looking at things like device, location, contextual factors, time of day, IP address. And by combining it together, we've got a lot of things that we can look for. Grant access to a specific resource instead of saying the entire network. So there's lots of these deployment models. There's cloud hosted models, zero trust as a service. There's on-premise solutions. And that kind of brings us into secure access, secure edge. And that's going to provide these network security functions along with this wide area network and proxy into a cloud native sort of solution. And it's kind of designed for that cloud first, mobile first world where we've got everything distributed all over the world. And because we're not necessarily in the same environment where we used to, where perimeter-based controls are enough, like a firewall or a proxy server or a secure gateway, we might need more. So we're going to be using firewalls, next generation firewalls, cloud access security brokers, data loss prevention tools, threat intelligence filtering. We're going to be using it all. And some basic features of SASE, they basically shift the filtering and the security functionality to the edge of the system, near the users. They basically provide and use a centrally controlled endpoint agent and a global network of points of presence to be able to connect into. And that way it eliminates inefficient routing. We've got any kind of wacky backhauling or hairpinning by the security functions being executed locally. And these types of environments typically align well with zero trust principles because they ensure granular. All right, we're back. We've been talking security. We've been talking about some networking things and SD-WAN and zero trust. So I think all this stuff is fun, but I kind of like networking. Admittedly, networking was my first tech job, and I actually only went into networking as a job because I liked it so much, and I was buying so much networking gear just to play with it because I thought it was cool. That my wife said, maybe you should have a career in networking. Maybe internal medicine could be your retirement hobby job where you do it as a volunteer and go work in networking. And that's kind of what I did. And that started all of my other architecture roles. So I like talking about these things. So I hope you are all learning more. Does anybody have any questions right now? If not, we've got about 20 more minutes of content, 25 minutes more of content for the day. I'll give people a couple of seconds to see if that's true. And if not, as a reminder, if you just joined us and you're having a good time, maybe hit the like button, subscribe to the channel, hit the bell, those kind of things. As a reminder, if you just joined us, we've got a completely free guide, a study guide that'll be in the description of this video. Now, if you're watching us live, my team will drop it into the chat box in order to make sure you have it. But no matter what, I want to make sure you have this comprehensive cheat sheet, like a 400-page set of cheat sheets to really help you in your cybersecurity career. It's free, so please get them. And I don't see any questions coming in, so give me a hashtag CCSK. We'll do about 20 to 30 more minutes for the day. And then after that, it's day 3, completion, party time for the CCSK Certificate of Cloud Security Training course for the CCSK V5 exam, for the CCSK certification. So no questions. Give me a hashtag CCSK. And Chris, let's get back to the content. It may take us a minute or so to get back to the content. Normally speaking, I don't normally pre-record these kind of things, but my back has been a little challenging. It's a 20-year-old problem that I had from being a firefighter paramedic in my youth, and too many ambulance accidents. So it's too much work, too many carrying people down the stairs. So, I don't know what each day is like, so I pre-recorded them. So bear with us on that. So Chris, let's get back to the content. I just wanted to make sure I could have something for you and be here no matter what. Now we're going to be discussing Domain A of the Cloud Security Alliance Certificate of Cloud Security Knowledge, CCSK exam. And it's going to be about workload security. And that's going to be the context of what we're going to talk about in this section. So what is a workload? So a workload is something that's going to have to be done and or be processed or be performed. You can think of it as a set of software and maybe some data units that are going to be deployed on some kind of infrastructure to do something. Now that infrastructure could be a virtual machine, it could be a container, it could be a function as a service, but this is where the workloads are going to be run. And depending upon where we actually run our workloads, that will ultimately determine what we're talking about is the security level as well. So we'll have to think about different security for different workloads. Now, remember, this is going to be a shared responsibility thing because the cloud provider may be hosting a lot of that. So if we're dealing with infrastructure as a service, the cloud provider is managing the underlying server and the hypervisor. If it's a container, potentially they could be managing the entire container hosting strategy and the virtual machine that sits on and its operating system and the underlying virtual machine, the hypervisor, and the service. So based upon what we're actually doing and where the workload is going to run, it'll talk about the differences between who owns what from a security perspective. Key to remember that cloud workloads could be a little different. They're often very dynamic. They evolve very rapidly. They become very agile, and they're very adaptable, where things are much more static in the data center. A traditional data center, anyway. Now, things get fairly complex because we could have different workloads running on each and every kind of compute platform. We could have 10,000 servers, and it's not going to be uncommon, and thousands and tens of thousands of virtual machines, and a whole bunch of functions as a service, too. And whether we're dealing with serverless functions as a service, obviously they run on a server, but they're a provider server, and we don't even know. So virtual machines are basically a virtual server, and they run on the actual server. I know we've drawn these before, but just as a reminder, maybe we whiteboarded out one more time. We've got our underlying infrastructure, which is the physical server itself. We have the hypervisor, typically speaking. And then we've ultimately got our virtual machines, and our VMs will basically each have their own OS, their applications, and their dependencies. And we'll have multiple virtual machines sitting on the server, and they're isolated from each other. Now, this is a little different than the container. And, the container typically, regardless of how it's going to look, could either be on the physical server or most likely what you'll typically see for convenience purposes of moving it around is you've got your physical server. You've got to have your hypervisor. you're going to have a big virtual machine, and it's going to be, and so this will be a big VM. And on top of the VM, what we'll have is a container runtime module like Docker or something else. And then ultimately we'll just have our containers, and our containers will basically, this will be the container, and the container will have the application and its dependencies with no without anything else. So no operating system, what have you. So there's that. So we could be hosting a containers on a virtual machine like this that we own, or the cloud providers have a serverless environment where you just stick your container there and it runs if you don't manage the capacity. But at the end of the day, it's still going to be running on something like this behind the scenes. It's just the cloud provider will be managing all of it. You will. Now, those functions as a service, again, are just upload your code and it runs. And the cloud provider manages all this infrastructure. So here, the security that we have to deal with is just the code and the permissions. So you can see in one with the virtual machine, we're securing our operating system, our dependencies. In a container, we're basically securing the container, but we're pulling that OS kernel from the provider itself. In the function as a service, it's basically our code and our IAM, and there's nothing more we can do. Of course, we could also be dealing with AI workloads, which could ultimately handling very big data sets. Very big data sets may demand some significant security. So we have to remember there's back and forth between us and the cloud provider. No, we want to figure out stuff that's cloud aware. We want to have endpoint protection on our devices and some kind of endpoint response because we want to minimize our attack surface. And there's plenty of context-aware security agents that we can put on our devices, and they can work. And some of them are behavioral-based, where they can start to see things are going on. But there's lots of ways we can get information from endpoint detection and endpoint response systems. We want to be monitoring systems. We want to be gathering workload logs, storing our logs maybe in a central place, and maybe even a scene system. And we want to be able to collecting information to help us. Our systems, we will have to determine how safe they are. So we're going to want to perform vulnerability scans on our virtual machines, our container images before we deploy them. And we want to conduct heavy offline assessments before we even put things up. We don't want to put up bad code. And the reality is you're not going to be able to test your stuff on the cloud as hardcore as you might in a test environment. For example, we can run the denial of service type attacks in the test lab. We can even do it on an environment because we owned it, but we can't simulate a distributed denial attack on ourselves going into the cloud provider because they may not let us. So we may have to do more testing before we deploy in the cloud than on the cloud. Keep that in the back of your mind. We should be using cloud workload protection platforms, and these are going to be tailored solutions that will combine vulnerability scanning, log collection, runtime protection for our cloud workloads. And remember, we're probably going to be in multiple clouds, so we're going to need something to help us with that. Now, how do we secure a virtual machine? Well, there's a lot of things. We have to secure the virtual machine's operating system. And that typically means removing unnecessary packages, closing unnecessary ports. It typically means patching it to the latest level of patches. It typically means isolating our virtual machines from each other, potentially being put in different subnets, for example. And it means creating a strong-based hardened image. And maybe in many cases calling that the standard operating system image. And use that as a base. Certain services removed, hardened to a certain level, a certain kind of endpoint protection, and use that as your base again, and again. Now, cloud auto-scaling can really enable an organization to adapt to changing demands. This can be a great thing. Send 50% of your workload to one cloud, 50% of your workload to the other cloud. One cloud disappears, and the other cloud is within 45 minutes is at full capacity. So we also have the ability with auto-scaling to use smaller stuff based upon aggregate needs and then scale out when we need the capacity. Think of a retailer. Think about their normal site. People don't buy crazy every day. They buy crazy near Christmas time. So what happens is they need, in a normal environment, they build out for Christmas time the biggest demand. In the cloud, they could build for average demand and then add auto-scaling near Christmas or something like that, or during periods of sales or heavy use. So we want to keep that in the back of our mind. So let's talk about virtual machines and how we would challenge them. We want good images. We want to patch them. We want to minimize the attack surface, which is why we remove those unneeded components. We want to use access control, like implement the least privilege. Don't give people the ability to do more stuff on the system they need. We want to use automated tools to scan, patch, report. We want to optimize our configurations for consistency by using good, strong infrastructure as a code based upon something the organization has approved. We want good monitoring and logging to track what's going on in these virtual machines. When we administer the virtual machines, so use SSH to configure them. Use host-based firewalls, but realize you're going to need a lot. Make sure these machines have a secure boot so they can protect against malware before the OS even loads. And use whatever specialty security tools you need to monitor your hypervisors, detect unusual activity, whatever you could, at least if it's on a system you own. Now let's talk about creating secure virtual machine images with factories. So an image factory is basically an automated pipeline for building a customized secure virtual machine and an image that you can use again and again and again. For image sources, we can think of the underlying components where it'll put the right operating system, the right libraries, the right configurations, and that's going to be our image that we're going to be used. The key here is to ensure that every time we need to deploy something, it's going to be simple, it's going to be uniform, and it's going to work, and it's going to work well. So let me map it out for you, things that it could honestly look like. So we're going to have image sources, right? And where are they going to come from? We want the images to be, or the source images to be coming from somewhere that we trust or want. So we want to make sure that they're coming from an approved or a recognized source. Now over here, now we can put this into an image factory where we can create these things, right? So we've got sources of these things. Now here's our image factory. And now we're gonna automate taking this base image into making what we really need it. And realistically speaking, at this point, now we're going to have approved images that our users can use because we made them ourselves basis upon source information. So here's our good approved images. Now we know things that people can use. And we can even use this for secure image creation. And we can integrate the security into the image pipelines and into the image factories. So we've got some kind of secure image creation that we're using. And now what we're dealing with after all this is we know back and forth in both directions that now we're getting images that are good for our business. They're going to be secure. We're going back and forth. And this is a process to approve, deny, what have you, based upon the company's needs. So these image factories are going to have automated processes and tools that are going to help create these custom virtual machine images. And that's going to give us consistency, security, and repeatability. We're not going to have this thing there where they forgot to close this port and this thing where this port's open versus another port that shouldn't be there. We can build them, we can test these, we can refine these images, we can minimize any inconsistencies and configuration drifts and operating system drifts. We can streamline updates and changes because when we know what we're dealing, we know the packages, it becomes very easy to manage these systems. And obviously these image sources are going to be the core components for constructing the image, like the operating system, the applications, the libraries, configuration files. Now, these image sources need to be very carefully curated. We need to run security checks on them. We need version control, be able to roll back if we need to know what we're dealing with. Now, obviously, we have to harden these things. We talked about how to disable certain things. We're going to have to patch our systems and make sure our patches are good. We want to keep our images updated with the latest patches and security fix. We want to have standardized templates or scripts to ensure consistent security standards in our images, and we want to test them. Test each image before we use them. Make sure they actually work. Make sure that they pass whatever test we need to give them. And if you embed these practices from the time you create a virtual machine, we're constantly building the systems to resist threats. We're maintaining a more robust security posture from the beginning, which is where we wanted to start. And talk about some various tools. As I mentioned, we have these cloud workload protection platforms, which provide deep vulnerability scanning for our virtual machines, containers, serverless, and they'll prioritize findings based upon exploitability and impact. We still want to use traditional vulnerability scanners if we're able to. Now, sometimes they're just rebranded as cloud workload protection programs, but they can help us adapt to various cloud approaches. But we still want to use tools that can look into system. We want to use configuration management tools to automate patch deployments as well as hardening. We want to use endpoint detection and response systems to offer some runtime monitoring of the device. So we put some endpoint detection and response that's sitting on our devices, it's watching, it can help us. And obviously, we need to be logging these things real time, monitoring, porting with our SIEM systems. So let's talk about the vulnerability management lifecycle. The first thing we need to do is find whatever vulnerabilities or weaknesses we have, right? So we have to identify them. And we may use automated scanning tools or other scanning tools to find out what our weaknesses are. Identify first. Now, once we know what our weaknesses are, now we can do a risk assessment on the virtual machines, the data classifications, whatever we need to do. Identify first. Here's what you got, and then assess. Is it big? Is it not big? What do you need to do about it? And then, of course, we need some form of mitigation and reporting where we need to patch systems, adjust the security settings, address vulnerabilities, or document any actions taken. And of course, in a cloud environment, we want some type of immutability where basically we're replacing virtual machines with updated images that can be more efficient than, say, patching a live system. Because a new system might be a little easier. So we really have to want to go through this again and again and again. We want to identify. We want to assess what we're dealing with. We want to do whatever we need to, and then we want to document it. So if you really think about all of this, we don't really know what our risks are until we identify them. So we have to identify. And after we identify, we have to figure out or assess what we really have. So we have this concept of an assessment. And then and we want to go and all day, we can't keep doing this because we're constantly going to be finding new things. And then we want to assess the impact, the severity. So then we want to do something. We want to fix it, right? So we found something. We identified something. We're going to have to fix it. So let's go to this particular situation over here. We found a risk. We identified it. We assessed the risk. Now we got to document it, right? We got to mitigate it. We got to mitigate the risk, whatever it was. So we found that a problem with the operating, there was a weak bug that we found that we identified. We assessed it to be something that's medium priority. We finally mitigated the risk, so we got to mitigate it. And, after we mitigate it, we've got to tell others about it, right? And then we probably have to document it because if we don't document that we fixed it, nobody's going to know. So again, we'll mitigate this risk. We'll document the risk, and guess what? We're going to do a new scan, and now we're going to find a new risk, and then we're going to assess that risk, mitigate that risk, and then document it. And we're going to go back and forth. So let's talk about snapshots, and we'll also talk about things like public exposures and exfiltration. So what is a snapshot? A snapshot is an identical copy of a storage volume that's used for preservation. So what does that really look like? Let me show you. So let's say we've got a server's virtual hard drive. So we're going to have a virtual machine over here. The virtual machine will have some block storage, and its name will change, whether it's a managed disk or elastic block storage, but it's going to be block storage that's used as a virtual hard drive. Well, and what'll happen is we can take this server image and we can, with this entire server and that entire hard drive, and we can create an image or a snapshot. Now this snapshot is going to be a bit by bit identical copy of it. So we can back up the virtual machine in a snapshot. We have the snapshot, and then we could launch the snapshot into another virtual machine if we needed to, because that snapshot is a virtual machine. So it's a new VM if we had to. And this is one of the ways we tend to back up systems on the cloud. So if the snapshot includes the full virtual machine state, its files and its settings, Well, if this information was leaked, it could be a security thing, which means that we're going to have stringent access controls on our virtual machine snapshots and limit who can create or retrieve them. We may need to protect or encrypt the data in the snapshot in case it gets compromised or exposed. We want to have some lifecycle management where we regularly review and delete unneeded snapshots to minimize the risk and obviously optimize our storage costs so we don't keep storing stuff we don't use. And we want to monitor these systems and these snapshots for unauthorized access. And we have to treat the snapshots with the same level of security we would a live system because, like that, they can be turned into a live system. All right, we are back. Let's see if anyone has any questions. So, as a reminder, tomorrow we have a webinar from 11 a.m. to 1 p.m. It's normally the 1 to 3 p.m. webinar, but this webinar will be focused on how to become a security architect. We'll go over the role. We'll talk about what security architects do. We'll actually talk about the right set of skills, and we'll show you why it really doesn't matter your background and how you can get there, because I can go over and talk about how every one of us, no matter where we come from, all has something that we can offer and all have some of the skills that you need. But no matter what job it is, for the most part, there'll all be gaps, and we can all learn those gaps, and we can all do anything we want. So today we're done for the content, unless anyone has any questions. So we'll see if anyone has any questions. I hope we've all been having fun in this cloud security course that we've been running. I know I have, and I hope everyone else has been having fun. So I'll see if anybody brings in any questions, and if not, we try to finish around 5, and I think we pretty much did it. So let me just check for about 30 seconds to see if there's any questions. Otherwise, we're excited to see you. We hope to see you on the webinar tomorrow, and we'll be happy to see you again tomorrow for between 2 and 5 for the next day of the CCSK training. Okay, well, I don't see any questions, so I'll see you tomorrow. If you had a good time, please give it a like, subscribe to the channel, hit the bell to be notified of new things. Do check out the description of this video for guides on how to become an architect, like a cloud architect or a security architect or an AI architect. Do check out the description for guides on how to win the interview. And we have more tomorrow. Balraj, it was good to see you. Richard, thank you so much. Thank you so much, Ben. And Adrian, I'm so happy to see you here. And thank you for putting the CCSK. Pablo, absolutely thank you as well. And SDO, thank you for the CCSK. I love knowing you there, Parviz. That's terrific. I think Parviz brought in a question, which we can definitely answer. To do disaster recovery with virtual machines in AWS, do you need to restore from a snapshot, or will you also need the machine image? So it kind of depends on what you're doing and what kind of disaster recovery you're doing. So option one would be basically you have your data center or whatever your cloud is, say Azure or Google, and then as you move over to what you do is you keep a virtual machine image, a machine image of what you would have, which is basically going to be the same as a snapshot. You take a snapshot, and the snapshot is an image. Well, you're going to create an image, whatever you want to call that, Amazon machine image, if you will, and you'll take that image of your system, and then you'll leave it over in AWS. And the cheapest option you would have is you use an infrastructure as code script to spin up all the virtual machines that you already have set up, and your data is going to be backed up. Now, Parviz, we can make that a little faster by basically, let's say, keeping our data synchronized between the data center and AWS, and potentially even our database is synchronized, but we still have those AMIs or snapshots or images of our virtual machines. That would be fine. Now, if we move into higher availability solutions, Parviz, like where we have our data center as is, and then we run a small version of it as sitting in the AWS cloud. You could call it a warm standby, if you will. No, in those cases, it's not going to be about the snapshots at that point. It's going to be about having active live systems. They can just scale out using auto demand when the capacity is needed. And of course, part B is if we run a hot data center and a hot disaster recovery environment with the same capacity, well, then we're always up and always running, and then we don't need the AMIs. But we'll be definitely creating snapshots or virtual images of the machines we have anyway, because we've got to back up our systems, and that's the perfect backup. When we take a system and we back it up into a snapshot, not only for everybody else that's here, not only does it have the operating system and the applications, it's already pre-configured and ready to go. So just launch it and poof, everything works. You may have to change the DNS that points to it because it'll come up with a new IP address, but all in all, it's up and running like that. Great question, Parviz. Vishami, you're welcome, and thank you so much for attending. And thank you, Roger. I'm so happy you're here. Adelabrad, I am thrilled to see you here. Michael, always good to see you. Michael, I know outside of here you're doing great and all your architecture things. Duncan, same for you. It's always so happy to see you. And you're here from New Zealand, so I know you've been here for some potentially uncomfortable times as well. So thank you so much, Duncan. And for any of you that are coming in from wacky time zones, and I know some of you are, and by wacky, I mean late at night, early in the morning, not that the time zones are wacky, because we could be in the wacky time zone here in Florida, but, I know what it's like to be attending calls and meeting with people at Singapore at hours that were definitely not the hours I would have normally kept, for example, in the US. So thank you so much for being here as well. And if you're doing that to enhance your career, congratulations. You'll definitely do well. So as would anybody that works hard. So thank you so much for being here today, and I look forward to seeing you tomorrow. Take care, everybody. Goodbye.